Alright, you guys, so for number one, we have that the following data show the heights in meters of 6 players in a basketball team. So the first player has a height of 1.67 meters, the second player has a height of 1.6, and the last player has a height of 2.19 meters. And so for part A, for these 6 players, you need to find the mean height, the median, the modal, and the range. Now all of this is very, very easy, but what we might be confused about is what each thing means. So once we understand what each thing means, this will turn out to be much easier than expected. So for part AI, okay, for part AI, we need to recall that mean, okay, mean is the same as average. They are synonyms. And for the formula for mean, well, you should go to your formula booklet. Ladies and gentlemen, the day of the test, you're walking in with just a couple tools, your pen, your pencil, your eraser, your calculator, 2 years of experience of this thing called IB, 2 hours of sleep, and the formula booklet. So get familiar with the formula booklet. It will help you do better the day of the test. So once you get familiar with it, you read the word mean, you recall that it's average, and you remember that it's in your formula booklet. You open up the formula booklet and you find it eventually right over here. And so for mean, it's X with the little bar on top, ¿cierto? Which is actually a good reminder that in my calculator, it's going to show up with an X on a bar on top if I ever have to use it. And secondly, although this looks absolutely nasty, if you remember it as average, intuitively what you will eventually find is that this number up top is basically like your total of your data. So total data, right? Sum of total data divided by this n, okay, this n, that's going to be like your total data, but in terms of like amount, see? Now I know this isn't like the fancy math definition. I know this isn't like the textbook definition, but for me, intuitively, I like to remember that whatever's on top for mean is going to be the sum of my data, while down at the bottom is going to be the total data in the sense of an amount. What do I mean by this? If up top is going to be the sum, then for the median height, it's going to be 1.67, which is this first person, plus 1.60, which is the second person, plus 1.68, plus 2.31, plus 2.31, plus 2.19. So in that sense, I am having the sum of the total of my data up top divided by the total amount of my data. And when I say amount, again, it's not like the most fancy explanation, but for me, intuitively makes a lot of sense. What is the amount of my data? Well, I have 6 players in my data, so that's my amount. See? So in that sense, I'm saying amount, and in that sense, I'm saying sum. And here's a good point, you guys. In math and in life in general, there are a lot of different concepts that will be taught to you, okay? And you have to find a way that you remember it best. See? Maybe you're listening to this guy on YouTube saying, total amount, and you don't like it that I'm saying total amount. Maybe you remember it in a different way, ¿cierto? Maybe for you, it's more intuitive to say sum divided by total. Maybe for you that makes more sense. For me, this makes more sense, okay? To each their own, find a way to remember it. At the end of the day, this is how you solve it. You find whatever floats your boat. So you pull out your calculator, and because we're dealing with a big fraction, you can go alpha y equals, press the first one, that pops up a fraction. This is just for plugging in more easily so that we don't mess up any parentheses and stuff like that. Add up carefully because these are easy points. You can only mess it up by plugging it in incorrectly. Double check. Looks fine to me. Divided by 6. So for part AI, this is my method. I'm showing my method. And my answer is 1.96. Don't forget the units, meters. So that is for part AI. For part A double I, we have the median height. And so for the median height, this will be a little bit different. But for median, okay, for median, all you really need to do, or what I like to do, is that median, I can associate it to like the middle. Okay, so mean we will associate to average, median we will associate to middle. So it's the middle of my data. Now, if I ask you, what is the middle of my data in this scenario, there is one big observation we have to do, and that is that if you think about the middle of your data from here, well, this number is bigger than that number. So for the median, they have to be important in order. And so if I were to put these numbers in order from lowest to greatest, what I would end up with clearly is that my smallest number is 1.60. Then my next highest is 1.67. My next highest is 1.68. Then I have the 2.19. And then I have two 2.31s. In that sense, now I have my data organized from lowest to highest. Now it is in order, see? And so the middle of my data now, well, which one is it? Well, let's try to find the middle from here. If I take one off from each end, so one off here and one off there, I'm still not at the middle. If I take one off here and one off here, I'm still not at the middle. And notice, if I take one off here and one off here, it's like you end up with no middle, ¿cierto? So, important observation. Following this visual sort of approach of the green lines of like subtracting one on each end until you reach the middle, what you discover is that for even scenarios in the sense that you have 6 players, so 6 is your total, right? Your total amount of your data, and it's an even number. So whenever it's an even number, you will encounter this problem where you sort of have like 2 medians. What happens here, ¿cierto? It's not that you have 2 medians, it's that your median is between both. And so if your median is between both, what you actually have to do is take the 1.68, add it to the 2.19, divide that by 2, and there is your median. So what is between the two sort of middles, if you want to think about it that way, is you add both, divide by 2. Your median here is 1.935 meters. So for part AII, for the median, we have 1.935 meters. And just to show like the classic example, if we were in a scenario where our numbers were odd, for example, you have the data, I don't know, 1, 3, 5, 7, 9, and I ask you what is the median here, if you do the same exercise of cutting one off on each end again and again, you do end up with a single median. See, it's just that whenever your data is, what I'm gonna call it, even, so for example, the same scenario, just that now instead of having 5 pieces of data, so it's odd, we now have 6 pieces of data, so it's even. We encounter the same issues down here, because whenever your data is even, you sort of end up with like 2 medians, but you can't answer 2 medians. So you gotta take the 2 numbers in the middle, do 5 plus 7 divided by 2. In this scenario, it will be 12 divided by 2 equals 6. See? So a little bit of a longer explanation of how the median works, but now that you saw this, you never have to see it again. Isn't that nice about school? Anyways, that is for part A double I. For part A triple I, we have that we need to find, the model height. And so what I like to associate the word model to is the word most. So that's the first observation we're going to do. For part A triple I, we have that the model, or a lot of times you're going to see it called as the mode. Okay, I've also seen it as mode. We will associate it as the word most. So notice, in all these different scenarios, I am associating like a more intuitive definition, see? So mean, we will associate it to average, which in consequence makes you associate it to either this or this. Median, we will associate it to middle. Okay, and then you remember the visual aspect of solving it. And the model or the mode, you will associate it to the word most. And so the model height in this case is the height, quite literally, that shows up the most. And so which height shows up the most? We'll take a good look. The 1.60, does it show up again? Nuh-uh, you only have one 1.60. The 1.67, does it show up again? You have a 1.68, which is really close, but it's still not 1.67. So 1.67 shows up also only once. 1.68 shows up only once. 2.19 shows up only once. And ta-da! 2.31 shows up once here and once here. So 2.31 actually shows up twice. And so the model height, the height that shows up the most, is indeed 2.31. It shows up twice, while every single other one shows up only once. So for part AIII, the height that shows up the most is 2.31 meters. All right? And just so that we're on the same page, my answers thus far has been this, this, and this. And now for part AI4 or whatever, see, we have the range of heights, see? And now for the range of heights, I don't have like a more intuitive word to put here because range is already like pretty intuitive, see? So sometimes when we talk about like our range of options, it's all of your options, see? If you talk about the range of how far maybe a gun can reach, ¿cierto? It is from here to there. So it has a certain sort of interval. The range, we will associate it to, I don't have an intuitive word for it, but the procedure is basically just max minus min. Okay? Maybe remembering the examples I mentioned can be good. When we talk about a range of options, you're talking about all your options. And so if you're talking about all your options, you got to do the max minus the min. And so in this case, the maximum value here, the highest, is 2.31. While the lowest is 1.60. So for the range, it's quite simply, we will associate range to max minus min. And in this scenario, we have the 2.31 minus the 1.60. So 2.31 minus 1.60 will be giving me my final answer, which will be in pink. My final answer should be, I'm pretty sure I can do mental math here, but you know, we have a calculator, so why not? And let's be honest, all of us the day of the test, we put into the calculator even something like 10 minus 5. See? So, following that energy, over here the range is going to be 0.71 meters. And just so that you guys believe this guy that's online, not that you should believe guys that are online, but just so I gain your trust for this video, see? Over here, we have the answer key, see? So there you go, 1.96. Important to show your method. In this case, it wasn't so important, but it's important to do it. Whatever, show your method. See, 1.935 meters is what we got over there. The 2.31 for part III, and then here's the procedure, the method for finding the range, and there's the answer, 0.71. See, yeah. Last but not least, we are moving on to part B, and so for part B, what they actually tell us is that a new player. I'm actually not sure how to pronounce that. George? Whatever. A new player, George of the Jungle, joins the team. Their height is measured as 1.98 meters to the nearest centimeter. And so for part B, this is a classic, by the way. I've noticed that IB really likes to ask these sort of questions now. You need to write down the shortest possible height of George. Okay? So, his height right now is 1.98 meters, right? And notice, when they tell you, this is the key idea. When they tell you that his height is measured as 1.98 meters, blah, 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 to the nearest centimeter, that means that through rounding, you have to be able to reach 1.98 meters. And so, maybe let's do like a different example. See, before we do the 1.98. So if I tell you that through rounding, I reached, for example, the number whatever, like 40. See, so if through rounding I reached the number 40, that means I could have had as a highest value 44 that ended up as 40, or I could have had 35 which ended up as 40. Because 35, you look at the 5, you say, it's 5 or above, you round it up, you end up with 40, ¿cierto? Or for the 44, you say, it's below 5, so you round it down, you end up with the 40. So, in this case, what you have is 1.98. And so, technically, through rounding, I could have had the number 1.984. Because the moment that it's 1.985, you end up rounding it up. You end up quite literally rounding it upwards. See? So from like the upper end, or so to say, it has to be 1.984. Because if this is 5, you end up with 1.99. Okay, that's what this guy is saying. See? And from the lower end, ¿cierto? From the 35 to the 40, from the lower end, what you actually end up with is the number 1.9, and here you do have to do a little bit of critical thinking, 75. So if you have 1.975, it's 5, so you round it upwards, and you end up with 1.98. So this is for like the lower bound, if you want to think it this way, the lower end, and this is for the, upper bound, upper end. See? That does not look like the word upper. Let me try again. There you go. See? And so that being said, for part B, we need to write down the shortest possible height for George. And so for the shortest, it's going to be the lower bound. My answer is 1.975. Don't forget the units, meters. Bada bim, bada boom. It is right here. 1.975 meters. See? If they were talking about what is, or write down the highest possible height for George, it would end up being 1.984. All right, ladies and gentlemen, that is for number 1. And I think the biggest tip I can give you is that these questions about mean, median, mode, range, this, that, etc., the math is really not that hard. I mean, I think the toughest part for me, at least, is remembering what median means, what mean means, what modal means. And so associating all these little tiny details, like median is middle, because median, middle, el medio, ¿cierto? Mode and a model sounds a lot like most, so that can help you remember. Range, that happens more through like examples and stuff, but you still get the max min. And the mean is just a weird one. I don't know how mean ends up as average, but it does. See? So that's one of the few things you do have to sort of memorize, and the other ones you can associate it to terms that are more intuitive. See? Ladies and gentlemen, that is for number 1. All right, ladies and gentlemen, for number 2, we have that a teacher surveys their students to find out if they have eaten at the local Thai and Indian cafes. The results of the survey are shown in the following Venn diagram. So just so that we understand how Venn diagrams actually work, in this case, you have that for the Thai cafe, 10 of them only have eaten at the Thai cafe, while 23, because it includes the 10 and the 13, have eaten at the Thai cafe. So 10 have eaten only at the Thai cafe, and 13 have eaten at both the Thai cafe and the Indian cafe, and 8 have eaten only in the Indian cafe. See? So that is one of the first things we sort of have to point out of how Venn diagrams work. And this 2 out here, what's happening, no, it's not a typo. This 2 is people that have eaten at neither. So they haven't. Okay, they have not eaten at neither the Thai or the Indian cafe. So now that we got that out of the way, this is not that hard of an exercise, but you do need to understand the intuition of the Venn diagram. So for part A, we have to write down the number of students surveyed. So this is pretty much straight to the point. As I mentioned, this is the ones that only ate at the Thai, this is the ones that ate at both, and this is the ones that only ate at the Indian, and these are the ones that ate at neither. And I don't see any other number anywhere, and so all you really have to do for part A is add 10 plus 13 plus 8 plus 2. After some quick maths, you will end up with 10, 20, 33. 33 students. All right, so part A, very, very straight to the point. As you can see over here, it's 33. See? Yeah. Then for part B, we need to write down the number of students who have not eaten at the Indian cafe. So read this carefully. See, a lot of people here would probably write down 2 immediately and keep going because they said, they have not eaten. ¿Cierto? Yeah, not eaten at either is 2, but not eaten at the Indian, for me, it's a very visually appealing solution. Think about it this way. Those that have eaten at the Indian cafe are the ones that pertain to this circle here. See? And I know you might be saying, aren't we looking for the ones that have not eaten at the Indian cafe? And I will say, true, but a lot of times in these sort of exercises with probability and stuff like that, it's a lot easier to think about it backwards. If you're trying to find all of the students who have not eaten at the Indian cafe, first find the ones that have and then subtract it from the total. So if all of these have eaten at the Indian cafe, all you have to do for part B is add up the remaining numbers. And the remaining numbers will have to be, let me just cross this out a little bit more, ¿cierto? And so the remaining numbers, all it really has to be is this 10 and this 2. So for part B, you do 10 plus 2. The numbers basically outside of the Indian cafe, 12 students. I missed an S back there. There we go. So for part B, there's the 12. Look at that. Then they tell us that a student is chosen at random from those surveyed, and for part C, we need to find the probability that this student has eaten at both the Thai cafe and the Indian cafe. So easy peasy points. We already established, but I'll do it once again because it's really important that you understand Venn diagrams, ¿cierto? This 10 is only Thai. This 8 is only Indian. This 2 is neither. And this 13 is both. Okay? So, for part C, find the probability that the student has eaten at both the Thai cafe and the Indian cafe. Well, your answer is not just 13. See? And so this is actually a cool distinction from part A and part B. For part A and part B, you need to write down each time, write down the number of, right? Write down the number of. For part C, it's probability. And so the big thing we need to understand when we're dealing with probability is that probability will always be, no matter which exercise, you guys, probability will always, always, always until you die, it will be your, think about it this way, like your part divided by your whole. Okay? Another way you can understand it is that this part is like your favorable scenarios. Like if I get more fancy with this definition for probability, it's going to be like favorable scenarios. And so in this case, favorable would be like the ones that have eaten at both divided by total scenarios. Okay, maybe that is a little more easier to understand. Probability is going to be total scenarios on the bottom and your favorable or the scenarios you're looking for up top. For me, it's more intuitively to say part divided by whole. I know that for some other people, they really like the word scenarios. See? So to each their own, understand it however you want to. For part C, your favorable scenarios or your part divided by the whole, well, your parts or your favorable scenarios are the ones that have eaten up both. And so you know that the ones that have eaten up both is 13. And you know that your total from part A is 33. And this is literally your final answer. You can leave probabilities as a fraction. Now, if you're scared to do that for whatever reason, take the 13, divided by 33, you can leave it as a decimal. So as a decimal, it's 0.39, never ending. And if you want to leave that as a percent, you can say 39.39%. Whatever floats your boat. For part C, they are putting all of them. See? Oh, and the significant figures I forgot to mention. If you want to do significant figures, you count 1, 2, 3. Do you round it up or keep it the same? You round it up. That is how you end up with 0.394. All right, so that is for part C. And later on, we have that we need to let T be the event as student has eaten at the Thai cafe, and let I be the event as student has eaten at the Indian cafe. And so for part D, you need to find what? What is this? What's happening? Ladies and gentlemen, welcome to the world of probability. No one likes it, but you gotta do what you gotta do, right? In probability, there's a bunch of different symbols that you have to learn and associate. And right now, I will give you a quick summary of what each of these are. If you already know them, you can probably skip ahead like a minute or two. Anyways, what you will be facing in the world of IB, AI, SL are these symbols. You're going to have the symbols, this one. You're going to have the symbols of this one. And you're going to have the symbols of this one. Okay? So, intuitively, this first one, it looks a little bit like what? It looks a little bit like an N. And so this first one is technically, okay, the probability of drawing X and Y. So this one is much easier to memorize for me at least, because the symbol that it has literally looks a little bit like an N, see? And so that reminds me that we're talking about and, okay? Yeah, so that's the probability of landing X and Y. This one down here, well, what's not the opposite, but maybe it is the opposite, I'm not sure. You have and you also have or. So this symbol here is going to be for or, okay? I don't have a friendly way to remember that besides the O being very similar to the U, okay? To each their own, that's what this symbol means, see? And last but not least, this one is the probability of X given Y. So all of these are probability of X and Y. Then here we have probability of X or Y. And last but not least, we have probability of X given Y. And the biggest observation I can do here is that each of these symbols, for example, this N, should remind you of the word and. This symbol here should remind you of the word or, and this symbol here should remind you of the word given. If you are more of a visual learner type of person, here's a quick Venn diagram that might help you. So if this is X and this is Y, let me draw one for each, okay? Yeah. So if I draw one for each, the probability of X and Y is going to be the intersection of both. So it's going to be right there. And the probability of X or Y is going to be the basically like the combination of both. See? So that would be X or Y. And last but not least, this is the weirdest one. X given Y is basically like you're within X, but you're drawing, sorry. X given Y is that you're within Y and you're drawing X. And you might be thinking, is it that the same as the first scenario? And the small difference that I'm about to point out now is the following. For the one up top, your total scenarios, notice, your total scenarios for the one up top is everything. Your total scenarios is quite literally everything. See? It's just that you end up drawing the intersection. Your total scenarios for this next one, for the or, is also everything. Your total scenarios is still everything. But the total scenarios of X given Y means that you're only in the playing field of Y and you end up drawing X. And so the big hint for given probability is that it changes your total. you can also think about it like it changes your denominator. See, it changes your total scenarios. But that is the main things you will be facing in AISL. And so if we come back to reality just for a second, this symbol, which one was it? Or. So we're talking about the probability, because there's a P here, the probability of T or I. Now, the probability of T is the probability of a student eating at the Thai cafe, and the probability of I is the probability of a student eating at the Indian cafe. ¿Cierto? So if we're talking about T or I, we're talking about this scenario here. As you can see, technically we're filling in all of this. ¿Cierto? Ba, 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 ba. And so your favorable scenarios in this case is going to be everything that's inside, 10 plus 13 plus 8, while the total scenarios, it's like the whole box, ¿cierto? So the total scenarios is going to be everything on the outside, and also everything on the inside, ¿cierto? And so, so your total scenarios are going to be 10 plus 13 plus 8 plus 2. So look at that. Doesn't it look pretty? Favorable scenarios is T or I, so it's going to be everything inside the circles, basically. And your total scenarios is still the two circles, the intersection, and the 2 that's right outside. So that's a small difference that we have to face. So for this part, you can go ahead, open up the fraction once again, because it's much easier, and you also feel very fancy putting in a fraction, let's be honest. And go ahead and add it all together, see what happens. Bada bim, bada boom, there it is. 31 divided by 33. 31 divided by 33. I'm not going to show the decimal places stuff because I did for part C, but just so you trust me, there it is. See? Yeah, so that is for part D. And last but not least, for part E, we have a fancy state whether the events T and I are, ooh, look at that, mutually exclusive. Justify your answer. So, what does it mean for something to be mutually exclusive? Mutually exclusive is a little bit like monogamy, okay? You are only with your partner and nobody else. And so if two things are mutually exclusive, that means you either are a student that only eats at the Thai cafe, or you're a student that only eats at the Indian cafe. Now, obviously, you look up here and you're thinking, I mean, there's people that eat at both. So that's already an argument for saying that the events T and I are not mutually exclusive. And so the other observation it can sort of show you is that if they were mutually exclusive, and this is something that I feel like not a lot of teachers show, but I think visually can help a lot because there are a lot of visual learners out there. If they were mutually exclusive, your Venn diagram would look like this. Here's your Thai, and here's your Indian. So notice how Thai and Indian don't even have an intersection. And why do they not even have an intersection? Because they are mutually exclusive. It is one or the other, but not both. That's probably the best way I can put it, actually. One or the other. That was lovely. One or the other, but not both. So if you want to remember this in a more intuitive way, there you go. One or the other, but not both. And so clearly for part E, you can write that out. You can literally write out like, there's students that ate at both. Como que, duh, ¿cierto? And literally, that will give you a point. Look at this. Except an equivalent statement is words such as, certain amount of students went to both cafes, or students can simply just go to both cafes, you know? And so and after saying that, your conclusion is no, they are not mutually exclusive. Okay? So that is one way to answer. And you are also observing all these fancy sort of formulas going all around it. See? And so another way you can solve this, okay, in case it makes you feel a little bit more comfortable, or just to add a tool to your toolkit, is that the moment that you read the words mutually exclusive, you should immediately be thinking, bada bim, bada boom, formula booklet. Now, not a lot of people do this because they're not familiar with the formula booklet. But I've done like 1 million YouTube videos and I'm pretty familiar with it. And ideally, the level that you reach, okay, as a student, is that you identify these sort of buzzwords, these key concepts, and you recognize them as things that are in your formula booklet. And I'm not saying that you read mutually exclusive and you remember the formula for mutually exclusive probability, but you should be able to recognize the words as something familiar and say, that's probably my formula booklet, okay? So that is what I mean by remembering these sort of buzzwords and stuff like that. Because the day of tomorrow, you might be solving an exercise that says, find the interquartile range, and you have no idea what it is, but it sounds familiar. And so you go to your formula booklet and you solve it easily. ¿Cierto? Or maybe, I don't know, whatever, it's like, you're trying to find the area of a triangle, you can't solve it with what you have, but you know that within your formula booklet, you actually have two equations for area of a triangle. You have the trig one, and you have the classic one, which is way up here. And so it's that sort of small itty-bitty details that can really save you the day of the test. Get familiar with the formula booklet. It's going to save you. It saved me, okay? Back in the day, a long, long time ago. So, that being said, eventually you can read mutually exclusive, you can recognize this as the formula booklet, and you will find it right here. So, basically what's happening is that if they are mutually exclusive, then this has to be true. If they're mutually exclusive, then this has to be true. So notice, the probability of A or B has to equal the probability of A plus B. Now, if I apply that over here, ¿cierto? So, right now they're asking for the probability of T or I, ¿cierto? So, if they're mutually exclusive, then the probability of T has to equal, if they're mutually exclusive, the probability of T or I has to equal the probability of T plus the probability of I. But if I go ahead and try that, what you're actually going to encounter, ¿cierto? Is that the probability of T is all of this, ¿cierto? It's all of this. And so for a probability of T, you end up with 10 plus 13 divided by your total, which is 33, found from part A, ¿cierto? And for the probability of I, which is over here in green, you're going to see that you're doing 13 plus 8 divided by 33. And what's the big mistake that's happening here? The big mistake that's happening here is that this 13, you're adding it twice. Quite literally, it's here and it's here. And so what you're supposed to do when there's an intersection, which is what they do over here actually, is that you get rid of that intersection at least once, so that you don't end up adding 13 twice, you get rid of it at least once. So if they were mutually exclusive, this wouldn't be a problem. But here it is, ¿cierto? So, probability of T or I, we found it from part D, which is 31 divided by 33, right? But if you actually try to add these two together and see what happens, you end up with 31 divided by 33, supposedly equaling 23 divided by 33 plus 21 divided by 33. So you end up with 31 divided by 33, supposedly equaling 44 divided by 33. Now you guys, 31 divided by 33, does it equal 44 divided by 33? No, it does not. See? And so because it does not, then since this statement was not true, they are not mutually exclusive. So your argument in this case is basically saying this right here, ¿cierto? So, which comes from this, ¿cierto? So because you ended up writing this out there, it's the same as saying this out here, ¿cierto? And if you're saying this out here, then you're saying that they're not mutually exclusive, okay? So that is just one more way to sort of find the answer. Whatever floats your boat. I'm just here to show you the tools. You are here to learn how you learn and how you understand things better. See? So, whatever floats your boat, stick to it. That is for number 2, and I hope it helped. All right, guys. So for number 3 over here, we have that on January 1st of 2025, the Faber Car Company, okay, will release a new car to global markets. The company expects to sell 40 cars in January of 2025, and the number of cars sold each month can be modeled by a geometric sequence or R equals 1.1. And so for some reason, they reach out to an IB student that's going to give the IB test tomorrow, and they say, hey, I need you to use this model to find the number of cars that we sold in December of 2025. The job market can be really weird sometimes. Anyways, what are the key ideas here? See? First things first. They tell us, as a fact, ¿cierto?, that we will be selling 40 cars in January of 2025. They also told us that this model of a geometric sequence where R equals 1.1 is based off of cars being sold each month. So for part A, we need to use this model to find the number of cars that we sold in December 2025. Now, first I will give you an overview of geometric and arithmetic sequences, and then I will tell you how to approach these exercises. See? So the first sort of thing I need to sort of teach you, and you can skip ahead if you already know, but an arithmetic sequence, okay, versus a geometric sequence, the main difference, you guys, is that the arithmetic sequence is a sequence that adds or subtracts, while the geometric sequence is the one that multiplies or divides. And to show whether it adds or subtracts, we talk about a common difference, which is going to be D. While for the geometric sequence, we talk about a common ratio, which is going to be R. Okay? So, an example of an arithmetic sequence could be something like 2, 4, 6, 8, 10. The common difference here would be 2, because you're adding 2 each time. Plus 2, plus 2, plus 2. And if you ever wanted to go backwards, you could also do minus 2, minus 2. See? Now we do think about it from left to right. But yeah, see? If you ever want to analyze it to a deeper level, you can do that. Okay? An example for a geometric sequence with an R equals 2 would be something like 2, 4. So right there you have times 2, ¿cierto? Times 2 again gives you 8, 16, 32. And so notice how up here, instead of adding, you're actually multiplying by 2. See? So that is a quick overview of the geometric sequence and the arithmetic sequence and stuff like that. The last sort of detail that I have to mention is that this first term here that I'm putting now in, I don't know, orange, ¿cierto? This is literally your first term. You call this U1. So the U1, U2, U3, U4, U5 only makes references to your terms. So U1 in this case is 2. This is U2, this is U3, this is U4, this is U5. Yeah, over here it's the same idea. U1 is 2, U2 is 4, U3 is 8, U4 is 16, U5 is 32. And so why am I mentioning the U1, U2, U3, U4, U blah, 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 blah? It's because in your formula booklet, the moment you read geometric sequence, or the moment you identify that you have a geometric sequence, you should be running to your formula booklet and saying, help, help, I don't know what to do. And what the geometric sequence is going to tell you is, voila, I've got these formulas here, good luck. And so notice, a big part, I think, of the IB math exams is really just understanding the formula booklets and getting the best out of it. So you recognize that you're dealing with a geometric sequence, you have the general gist of it as I wrote it down here, and all you really have to do from there is identify which formula to use. See? And so the cool thing about the formula booklet in terms of arithmetic and geometric sequence is that it is very, 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 very well organized. Up top, you have the arithmetic ones, while on the bottom, you have the geometric ones. And the other thing you can sort of identify is that they both have two sets of formulas. The upper one for both is for nth term, and the lower one for both is for the sum. And that's all you really need to know. What else can you sort of like identify? Is that, for example, for each formula, you need to have very, very clear what you need in order to use it. And so up here, technically, what you need for this guy, ¿cierto?, is un, u1, n, and d. If you have 3 out of 4 of these, you can find the remaining one, ¿cierto? For example, if you plug in, which is usually what happens, if you plug in u1, n, and d, you're going to find un. And if somehow you have un and u1 and d but not n, well, you can find n from there, ¿cierto? So always having at least 3 of them, or like all of them except one, ¿cierto?, will allow you to get that last one. ¿Vale? What can I do? Which sort of observation can I do for the next formula? You can notice that right here, there's a semicolon. See? So if there's a semicolon, that means that these two sum formulas will give you the same answer, but they ask for different stuff. Notice how the one on the left is asking for S of n, u1, and d. ¿Cierto? While the one on the right is asking for S of n, u1, and un. So, the big difference is that in one of them, you need to plug in d, and in the other one, you have to plug in un. See? Now, I do not expect you to memorize this and know this by memory, ¿cierto? That there's a slight difference in that one part in the formula booklet in arithmetic and geometric. No. Not a lot of people know that by memory, and you're not supposed to. But what I think you are supposed to do is that you need to be familiar enough with the formula booklet so that, first of all, you recognize geometric sequence. That's in my formula booklet. You go crying towards it, and you recognize, cierto, you have arithmetic ones up top, geometric ones down on the bottom, and I have nth term and sum for both. This guy online told me that there was a difference between the two formulas. What was it? Well, take a look, write it down, write it on the formula booklet, figure it out. Okay, so vaguely remembering that there's a difference is good enough, because the day of the test you will take 30 seconds to recognize what the difference is. But if you're not aware that there's a difference, you might use the wrong formula, you might never recognize that there's a difference between the two, and you're never going to solve the problem. So that is the level we have to reach. See? To finish with the introduction of these formulas and stuff, this one over here for geometric is now asking for un, u1, r, and n. So awfully similar to the terms, to the arithmetic one, just that instead of d, we are using now r. Okay? Yeah. And then down here, well, now there's an equal sign. See? So instead of having two different formulas that do indeed ask for two different things, one of them is asking for d while the other one's asking for un, the one down at the bottom is quite literally the same. They are both asking for S of n, u1, r, and n. So down at the bottom there is no difference. For the arithmetic ones there is. Yeah. Now in this context, back to reality. I know that was a lot of blah blah, but I think it's essential that we all have clear what the blah blah of this problem is. For part 3a, we need to use this model to find the number of cars that would be sold in December of 2025. So it's not asking for total, it's asking for the exact amount of cars that will be sold in December of 2025. So right now for part 3a, or for part 3 in general, what you have, ¿cierto? And having into consideration the context of the u1, u2, u3, and all that stuff, you have u1, because the geometric sequence is the number of cars sold each month, and you know that for u1 you sold 40 cars. So immediately you can already say for part 3a, or for part 3 in general, you know that u1 is 30. What else do you know? Come on, what else do you know? You know that r is 1.1. And so for part 3a, they're not asking for the sum, like the total sum of all the months. They're asking for that specific month. So you have to be using this guy right there. So this guy right there is going to be for part 3A. And this guy right there is, my formula is UN equals U1, times R to the power of n minus 1. So right now you have U1 as 30. So check. ¿Cierto? Right now you have R as 1.1. You have check. But you don't have n. And so notice, and here is a very important concept we need to grasp. See? So because we're looking for the number of cars sold in December of 2025, well, which term is that? So notice, if we're saying that U1 is January 2025, then you're telling me that U2 is February of 2025. And if you keep going, eventually, very obviously, U12 is December of 2025. So, what you're looking for is U12. And so if you're looking for U12, just plug it into your formula, ¿cierto? You're trying to find U12, see? And so if you plug in U12 over here, you just made a massive approach in your exercise, see? If you plug in U12 here, which is what you're trying to find, ¿cierto? Notice, and this is very important for us to grasp, and it's usually the hardest thing to explain, see? Your formula has an n right there and an n right here. And the moment you say that you're trying to find U12, well, you plugged in 12 for n. And the moment you did that, you're saying that n equals 12. And so now, for this exponent, you can put 12 minus 1. So the moment you recognize, and that's the weird thing, like finding n, it's not really that you find it, is that it depends on what you're looking for. And so if you recognize you're looking for December, which is U12, U12, n is 12, see? So finding n sort of depends on the situation. While U1 and R are given to you, n is something you define on the way. That's the biggest hint I could give you, and that was actually a very good way to put it. So this is given, while n depends, find on the way. So depending on what they're asking for, you will discover it and find it on the way. See? So enough blah blah. What you end up with is U12 equals 30 times 1.1, following the formula, ¿cierto? To the power of 12 minus 1. So plug all of this into your calculator. What you end up with is, well, let's find out. So you end up with 30 times that 1.1, and that 1.1 is to the power of 12 minus 1. So U12 has to equal 85.59. 35 cars. See? Now you might be thinking, how are you going to find like half amount of cars and stuff like that? Shouldn't it technically be just 85? And if we look at the answer over here, we recognize that we did a massive mistake. So U1, I'm very glad that happened on screen, and I'm going to leave it in the video because everyone makes mistakes. See, the massive mistake I did here is that for some reason, U1, I left it as 30 instead of 40. It's just a brain fart. I'm not sure what happened, but it happens to anyone. That's why I'm leaving it on the video. U1 is 40. Go slowly, go carefully. That's all I can say. See, U1 is 40. I'm not sure why I put 30. If you noticed, good job. If you didn't, good job as well. We're all learning on the way. We all find out on the way. See? Anyways, changing my formula ever so slightly to be 40 instead of 30. And now looking at the answer, okay, it makes sense. You end up with 114.124. See? So, my bad, happens to anyone, leaving it in the video just as a learning moment. I think it's good to show your mistakes because we all make them. See? Yeah, so U12 ends up being 114.124. So that is for part 3A. And then for part 3b, we need to use this model to find the total number of cars. This is good, interesting. Total number of cars that will be sold in the year 2025 and 2026. So this one is definitely a little bit more exciting. See? Now, for part 3b, it's fairly simple because, I mean, for 3bi, 3b double I gets crazy, ¿vale? But for 3bi, if we're looking for the total number of cars that will be sold in the year 2025, you are going from January 2025 over to December 2025. See? And that's very similar to what we just found. We did identify that that is technically from U1 up until U12. And so if we're doing from U1 up until U12, it's a big hint on how to apply this formula here. So this is for the sum of geometric sequences. The one on the left is the same as the one on the right. It doesn't matter which one you use because they do ask for the same stuff, so don't worry. I will use the one on the right because I'm a rebel. See, whatever. It's the one that comes second. I don't care. I'm using the one on the right. So the formula for that, ¿cierto? Is, I'll do it down here. So S of n equals U1 parentheses 1 minus r to the power of n, close parentheses, divided by 1 minus r. See? Now, a lot of this you have already sort of identified. See? So you've already identified, for example, that U1 is effectively 40, not 30. Dale. You know that R is 1.1 from the exercise. So that checks this and this, ¿cierto? And now you just need to define N. And so N, because we're talking about the year December 2025, and we're talking about from January 2025 to December 2025, your N has to be 12 once again. So N equals 12. If you plug all of that into the formula, better said, you end up with S of 12 equals U1, which is 40, parentheses 1 minus R, which is 1.1. So 1.1 to the power of N, which is 12. All of this divided by 1 minus R, which is 1.1. So yes, this looks nasty, but follow the formula and it's going to work out. So you pull out your calculator. We put a fraction because it makes us feel cool, but you do alpha, y equals, press the first one, and you can start plugging in from here. Got it? So it's 40 times 1 minus parentheses 1.1, close parentheses, exponent 12. Pop yourself down, don't mess it up. Put the parentheses again. And then down here, it's going to be 1 minus parentheses 1.1. See? I know that some of these parentheses are like extra, like the one down there. But for me, it's easier to plug in. Okay? So to each their own, whatever works. Bada bing, bada boom. The sum of cars sold from January up until December, or better said, the sum of cars or the sum of terms from the first one to the 12th is 855.371. And then we check over here. That is exactly what we got. See? Yeah. Now, that was for part 3bi. 3b double I is kind of crazy. See? And this one is a lot harder to solve. There's a couple different ways to think about it. And I'm going to show you what I consider to be the most intuitive way to do it. See? So, let's do a little bit of a timeline here. See? Technically, we know that U1, ¿cierto?, is January of 2025. And what we just found was the sum from January 2025 up until December 2025. And so you just found using U1 and over here U12, you found the sum of all of this to be just around 855. See? Okay. And what they want you to find now is the sum of from January 2026, which is just one period over, so it's U13, up until December 2026. And so, what term is that going to be? Well, if you think about it visually, if you go from U1 to U12, this would have to go from U13 up until U24. Okay, so that is fairly simple to figure out. For me, with a timeline, it's much easier to do. See? Now, what I assume would work, but that it's harder to spot, is that you use the sum formula only for this. See? There's probably a way to do that. I'm not entirely sure, but there's gotta be a way. See? The friendlier way, I think, okay, is that you use the sum formula for all of this. So use the sum formula for all of this because you start from U1, which is more friendly, ¿cierto? Plugging in from U1, because you do have to plug in U1, okay? And then whatever you get for the grand total, subtract it from the year 2025. So you subtract the entire 2025, and that will give you your answer. See? So that is my current game plan. All that is really changing, or better said, what you need to plug in, you're still plugging in U1 as 40, not 30. You're still plugging in R as 1.1. And now the N, I just plugged in 12 for N, ¿cierto? Because we're talking about the year 2025. But now you need to plug in the N of 24. So you plug in the N of 24 from there. Well, all you really need to do over here, ¿cierto? All you really end up changing is this 12 to a 24. So here, ladies and gentlemen, which is what I'm putting in green, is 3,539.89. Let's go ahead and put the decimal places this time. See, 893. While the other one we know gave us 855.371. See? So, just so that we understand what's happening, the number in pink is cars sold 2025. The number in green is cars sold 2025 and 2026. And so if you want to find only the cars sold, for 2026, all you have to do is take the number in green, which is the years for 2025 and 2026, and subtract it from the number in pink, which is only 2025. More intuitively, you are subtracting from 2025 plus 2026. You're subtracting only the cars from 2025. And so clearly you end up with only 2026. See? That is probably the friendliest way to do that. So you take this number minus that number. We end up with 2,684.52. 521 cars sold for only 2026. See? So over here, as you can see, it looks just about right. See? 2684.52. Makes sense to me. See? So, ladies and gentlemen, for part 3B II, we did have to get a little bit more creative. And the main thing that helped me get creative was understanding how the formula works. See? So once you understand how the formula works, that it starts from the first term, okay, it made it much more easier to visualize this sort of timeline up here. See? Now, I know it's not always obvious. I know it's not always evident. But the best way to make it easier on yourself is understand the formula booklet, understand the formulas. Don't fall into the trap of, the day of the test I have the formula booklet, so I don't have to memorize any formulas. True. You don't have to memorize any formulas, but you do need to know which formulas are in there, how they work, how they look, how are they different. Ladies and gentlemen, that is for number 3. All right, you guys, number 4 is like a classic sort of interpretation and exponents problem. It shows up a lot in the IBAISL exercises. They really like to put, and here's the main idea, they really like to put variables on exponents. Like, they know that confuses people. They know it's hard to solve, but I'm going to give you a couple tools, or at least probably end up showing you the tool that I use in order to solve these exercises. Got it? So we have that a cell phone starts charging at 7 a.m. and while being charged, the percentage of power P in the phone is modeled by the function P equals all of this, where T, notice, important, T is the number of hours after 7 a.m. See? So for part 4a, we need to find the percentage of power in the phone at 7 o'clock. So the approach of these exercises, or what they ask for, honestly, in my opinion, is pretty much always the same thing. See? Part A tends to be like, what's the initial amount? What's the initial power? What's like, here's the thing. See? Here's the main idea. The variable T is the number of hours after 7. And so if they're asking for the power at 7, notice, T is after 7. This is for T. T is after 7. And they're asking for the power at 7. Well, if you are at 7 and T has to be after 7, T has to equal 0. Makes sense, doesn't it? And so that's the first sort of thing you have to acknowledge and recognize. A lot of people here freak out because they say, ugh, I have A and I have T. It's over. I'm going over to the next one. See? However, it's friendlier than what you think. For part A, quite literally, you just plug in T equals 0. And the moment you plug in T equals 0, everything becomes much more friendly. And you might be thinking, this guy's crazy. How is it that for part 4a, I end up with P equals 100 minus 60 times A to the power of negative 0? How is that going to be friendlier? What the heck is happening? I don't understand. See? Guys, I know this looks nasty, but it's a lot friendlier than what you think, because first of all, negative 0 isn't really a thing. So let's make it a little bit more friendly on ourselves. So let's put it as just A to the power of 0. See? And the next thing we have to do, which you probably have memorized, is that anything to the power of 0 is simply going to be 1. So this ends up being as times 1. So I end up with 100 minus 60 times 1, so which is basically just 100 minus 60. You end up with P equals 40. So for part A, quite literally, you're going to see it's not that bad. 40%. See? So P equals 40 means that for part 4A, you end up with 40%. Now, I probably went a little bit fast here, and there's more than one of you saying, what the heck just happened there? See? So, anything to the power of 0 equals 1. If you want to memorize it like that, you can. If you want a quick explanation, I will give it to you right now. If you want to skip the explanation or you already know, you can skip ahead a minute or two. Point is, in math, it's a lot of times called, more than a study of numbers, it's called the study of patterns. See, in math, there's a lot of different patterns that you can identify and learn and associate to. So, when you're dealing with, for example, exponents, because we are talking about a 0 on the exponent, see? If you have, for example, 2 to the power of 3, this is 2 times 2 times 2. ¿Cierto? Now, 2 times 2 times 2, what's happening here is that you end up with 8. Now, the step before that is that you end up with 2. Actually, no, yeah. You end up with 8. That it? 2 squared, you end up with 2 times 2. That gives you 4. 2 to the power of 1 ends up as 2. That gives you 2. And 2 to the power of 0, you end up with only 1. See? Now, what is happening in the in-between step? ¿Cierto? Because here I'm showing you the in-between step, and over there I left it empty. So what's happening? Well, what's the pattern that arises here? The pattern that arises here is, notice, if I want to go up, from 2 to the power of 0 to 2 to the power of 1, you have to do times 2. If you're going to go from 2 to the power of 1 to 2 to the power of 2, you have to times 2 again. You have to times 2 again. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. Makes sense. And if you want to go backwards, you have to divide by 2. So 8 divided by 2 gives 4. 4 divided by 2 gives, gives 2. 2 divided by 2 gives 1. And so, it's because eventually you divide the number by itself. okay, but what's this in-between step that this guy online wanted to show me? The in-between step is that in math, it is a rule that all numbers have a ×1 next to them. Every single number has a ×1 next to it. And so what's happening here is that, for example, there, when I divide by 2, you're getting rid of one of the 2's, you end up with 2 2's, ¿cierto? Here, when you divide by 2, you're getting rid of one of them, you end up with only 1 2. And here, when you divide by 2, now you end up with no 2's. You end up with only 1. Because this 1, it's a math rule, all numbers are always being multiplied by 1. I forget the fancy math name that it has. It was like the identity something. But point is, whenever you have an exponent as 0, it will equal 1 because you only end up with the 1. See? The other way you can sort of memorize it is that eventually you divide itself by itself, because in this step here, when you divide by 2 to go down, ¿cierto? You end up having this 2 divided by 2, you end up with 1. You end up with itself divided by itself. And yes, this does happen everywhere. 3 squared is 9, 3 to the power of 1 is 3, and 3 to the power of 0 is 1, because if you divide by 3 each time, eventually, right here, you end up with 3 divided by 3. I end up with 1. See? Enough blah blah. Anything to the power of 0 equals 1 for part 4a. Easy peasy. 40%. Then they tell us that the percentage of power in the phone reaches 75% at 8 o'clock, and to find the value of A. And so this, although it looks very, very nasty, it's a little bit more friendly than what you think. See? So you have to have, for all these exercises of variable and exponent, it's really a very hard context problem. That's what I think. These variables and exponent problems is really just a very hard context problem. And so notice, when they tell you that the percentage of power in the phone reaches 75% at 8 o'clock, well, which are your variables? You have your t, which is hours after 7. And your other variable is p, which is power. So when they tell you that it reaches 75% at 8 o'clock, all they're really telling you is that when, it's actually a little bit backwards, when t is 1, because we're talking about 8 o'clock. So 8 o'clock is 1 hour after 7. So when t is 1, p is 75%. Will you look at that? Wow, that's crazy, isn't it? And technically, I can't just plug it in as 75, because all of this is in percents. I can leave it as p equals 75. See? But point is, the hardest part about these variable and exponent problems, for my interpretation, is that it's a very hard context problem. So the moment they give you that you have 75% at 8 o'clock, this is the information that they're sharing with you. When t equals 1, you end up with p equals 75. And if you plug that into your calculator, you end up with 75. Actually, we're probably gonna need a little bit more space for this. See? So my formula is p equals 100 minus 60 times a to the power of negative t. And they just told you that when t equals 1, p equals 75. See? That is the main information that they gave you. So if I plug that information here, you end up with 75 equals 100 minus 60 times a to the power of negative 1. And from here, you need to solve. See? Now, you have a negative exponent. So that is another challenge we have to face. We just talked about exponents equaling 0. Now we have to talk about negative exponents. Negative exponents are not that harder, and we can follow the same pattern. And so the pattern, which was going downwards, ¿cierto? Which was also subtracting my exponent by 1 each time, ¿cierto? If we do it one more time, so if you divide by 2 here, you should end up with 2 to the power of negative 1. And so notice, if each of these times I was dividing by 2, dividing by 2, dividing by 2, well, what is 1 divided by 2? It's 1/2. Okay. So 2 to the power of negative 2, it's going to be 1 divided by 2 times 2. 1 divided by 2 squared. 1 divided by 4. Not that hard either. Or is it? See? So, ladies and gentlemen, point is, when you have a negative exponent, the big thing you need to associate it to is that you are effectively flipping it. So, negative exponents, let me write it here actually. Negative exponents flip your number. See? Let me give you a couple examples because I think through examples it makes a little bit more sense. If you have, for example, x to the power of negative 2, you flip your number so you end up with 1 divided by x to the power of 2. If I had 3 times x to the power of negative 4, the 3 stays up top because the 3 is to the power of 1 and it's positive, so it stays the same. But down below you have x to the power of 4. So whenever you have a negative exponent, it flips your number. See? Even in the scenario where you have 1 divided by x to the power of negative 7, you're flipping your number. And so if it's on the bottom, now it ends up at the top. So guys, the negative exponent, all it really does is flip your number and the exponent like follows it. See? So down here, you have a to the power of negative 1. All that's really going to do is that you're going to end up with 60 up top and a on the bottom. Just like this. Nothing else, nothing more. A is on the bottom and the exponent followed it. It's to the power of 1. Now I'm not going to write a to the power of 1 because it's obvious or redundant, but that's where the exponent went. See? So that's the first step, understanding that the negative exponent is going to be flipping it. And the next big thing we have to do is that this a on the bottom is like, it's like really annoying, isn't it? It sucks. No one likes it. No one likes fractions, let's be honest. But here we are, you gotta do what you gotta do. So, whenever you have an annoying variable on the denominator and you're having trouble solving it from here, what you can do is multiply everything by a. Because in this step, if you multiply everything by a, golden rule of algebra, you have to multiply everything by a. ¿Cierto? You can't multiply just one term by a, you gotta multiply everything by a. Although you end up with a bunch of different a's, this goes away with this. And you end up with 75a equals 100a minus 60. Which might not look too pretty because you have a bunch of a's going around, but it's much better than having an a in the denominator. So that is the other big hint. The first thing we learned here is that negative exponents, they flip your number. So the a went to the bottom. And if you have a variable in your denominator, which is something that no one likes, one way to solve for that is just multiply by the denominator. Multiply everything by a, get rid of that fraction, get rid of that denominator. You end up with 75a equals 100a minus 60. And I like to keep things positive, so I'm going to do minus 75a to both sides. What you end up with is 0 equals 25a minus 60. You can do plus 60 to both sides. So you end up with 60 equals 25a. Divide both by 25. A equals 60 divided by 25, which is, I cannot do quick maths there, 2.4. See? So lo and behold, a is 2.4, not that hard. See? Yeah, that is for part B. We just found that a equals 2.4. The big challenge there was handling negative exponents, fractions, stuff like that. And now for part C, you need to draw the graph of p equals blah, blah, blah on the following set of axes. Now, the first sort of strategy whenever you need to draw the graph is that you plug in x values and you get a bunch of different y values and you graph from there with all different points that you get. See? But work smarter, not harder. Your TI-84 is literally a graphing calculator. There's a button on it that says graph. Isn't that amazing? The future's now. Anyways, if you want to draw this graph here, now you can graph it because you just found that a is 2.4. So really what you need to be graphing is 100. minus 60 times 2.4 to the power of negative t. And this is graphable because there is only one missing variable. And so if from here you go to your y equals, you can plug in 100 minus 60 times 2.4, which is the a, to the power of negative your variable, ¿cierto? Negative t, negative x, whatever. So now it's graphable. And notice, a big part of the IB, whenever you graph, is that your graph has to be accurate. It has to be good. It has to be nice. That it? And one of the ways to make it look nice and etc., usually they have a couple of points. And let me actually show you, ¿cierto? One of the points tends to be that you have the correct general shape, ¿cierto? If I were to draw something like this, it would be completely wrong. It's off, ¿cierto? So have the correct general shape. And the other thing that can help you a lot is that you write down the points that you're cutting through. And so what I tend to suggest whenever you have to sketch or graph is, first of all, get the general shape, ¿cierto? You should be nailing the general shape of it. That's pretty standard. But the other set of points that a lot of people forget is that you should be putting the key points onto your graph. See? So what I would have done here is quite literally put there, I would put the point 0,40 right onto my graph. I would put the point 1,75 because we found it earlier, ¿cierto? They gave it to us right here with what's in green, ¿cierto? And well, this last part is a little more advanced, but just putting a couple key points is going to give you full credit. See? So popping the general shape, putting the key points, makes sure that you get easy points on the graphing section. See? I will never forget one of the days that I was in math class, ¿cierto? I also took the AB back in the day. And my teacher, the warm-up problem was to graph, ¿cierto? And so we were all graphing, and everyone was done in like a minute, ¿cierto? It was very quick. And then when we were done, he told all of us, like, you like all failed. See? And we were like, what? Like, we all had the same looking graph, but we all failed because we did not point out at any moment the key points. So keep that in mind. Getting the general shape is half the game. The other game is nailing the key points. So have that in mind for graphing, ¿cierto? Plotting them onto the point, like signaling it like this, is a very good idea for you to get full credit. Got it? So, that being said, right here, it goes from 0 to 125. So what that is basically saying is that your y min is 0 and your y max is 125. And your x min is also 0 and your x max is 5. Why do I mention this? Because that right there helps you define your window. So before pressing graph, or actually better said, if you press graph, more likely than not, you might be able to see your graph, but you're not going to see it how you want it to, ¿cierto? This exercise is asking you to draw the graph onto these dimensions from 0 to 125, from 0 to 5. And over here, it doesn't look like it because my window is off. So go to your window. Your x min, as we just said, is 0. Your x max is 5. Your SCL, just always leave it as 1. Okay, please don't change it. Your y min is 0. And your y max is 125. See? Now, actually, the SCL is something that you sometimes have to change. Let me explain it. Here, you jump from 0 to 1, 1 to 2, 2 to 3. And so each of these sort of dotted lines is 1. See? So your x SCL is 1 because each of these dotted lines increases by 1. While your y SCL, well, by how much is it increasing? It's increasing by 25. 0 to 25, 25 to 50, 50 to 75. So actually from here, if you want to have it like ultra perfect, SCL for the y, for the y is 25. See? So now we press graph, bada bim, bada boom. Now it looks a heck of a lot like the answer key, now doesn't it? See? And so from there you can go ahead and now you can plug in, or when I'm plugging, you can go ahead and draw. See? So on the one hand, I will get the general sort of shape very easily, going like this. ¿Cierto? Boom. But more importantly, for the full credit, remember, where are you starting? I'm starting at 0.40. How do you know that you're starting from 0.40? Because from part A, that's what I found out. You also know that you have the point 1 and 75. ¿Cierto? Not drawing a scale, but it doesn't matter as long as you put the points. You also know that you have the point 1,75 that comes from part B. See? And so that is probably good enough. And the last thing you have to notice is that there's like a line that it sort of like never reaches. ¿Cierto? It has a sort of, look at this, new concept. Asymptote. So here you actually have a horizontal asymptote. I mentioned this because it's very common for exercises with variables on the exponent to have these sort of horizontal asymptotes and stuff like that. So all that's really happening is that right here, it's a number that your function will never reach. That's basically what an asymptote is. It gets extremely close to it, but it's never going to reach it. If I press trace and I go all the way to the right, notice as my x value increases, my y value gets very, very close to 100, but it'll never reach it. You can go on forever and you're never, ever actually going to reach it. See? Just to show you so that you trust me. Well, by now you should probably trust me. But point is, you're never going to reach 100 because you do have an asymptote at y equals 100. See? So, anyways, that was more for part C. But the introduction for horizontal asymptote helps for part D. For part D, you need to state a mathematical reason, ¿cierto? So I did talk about this a little bit. State a mathematical reason why the model predicts the percentage of power in the phone will never reach 100%. So there's two main things that are happening. One thing, or one way to answer, better said, is that you noticed in your graph that there's a number it never reaches, ¿cierto? Actually, even if you go to table, pressing second on graph, and you start scrolling down, you realize, damn, you really never reach. I mean, here it reaches 100, but it's really because it's 99.999999999, ¿cierto? Just so you trust me a little bit more on that, if you go to trace, it estimates it to 100 because you end up with 9.99999. See? So the fact that on the table showed 100 probably confused a couple of you, but point is, it's putting 100 because you're reaching 9.9999999, and your calculator would rather leave that as 100. See? And so here we are already at x equals 14, which is roughly where my calculator was putting it as 100 already. ¿Cierto? And so it's not that it's actually, oh, there we go. It's not that it's 100, it's 9.999 something. See? Anyways, one argument you can do here is that you notice that you have a horizontal asymptote. See? That's this first sort of argument that you can give. It'll give you full credit. Bada bing, bada boom. And the other one that, for me, it's actually harder to spot. Maybe for others, it's easier. For me, I'm a visual guy, so the horizontal asymptote thing comes to me very quickly. But the other thing that can work out is that, A, you literally have 100 minus something. So the other mathematical reason is that you can say you have 100 minus something. And 100 minus something, well, of course, if you have 100 minus something, you're not going to reach that 100. And look at that. Over here, they tell you either you mention the horizontal asymptote at p equals 100, which is the same as y equals 100, ¿cierto? And you can describe it in words, ¿cierto? Or the equation literally has 100 minus a positive value, ¿cierto? And so it cannot equal 100. It's important, you guys, that for this part, although it's a context problem, they are asking for a mathematical reason. So if your reason is like, IB grader, have you ever met a phone that has more than 100%? That's not a good answer because they're asking for a mathematical reason, okay? You can't say battery may degrade or battery can't reach more than 100% because it's not a mathematical reason. Your mathematical reasons are either the asymptote or the 100 minus. Ladies and gentlemen, that is for number 4, and I hope it helped. All right, for number 5, we have that my man. I actually don't know how to pronounce that. deposited $100,000 into a savings account with a nominal annual interest rate of I% compounded monthly. At the end of the 8th year, the amount in the account had increased to $150,000, and for part A, we need to find the value of I being the annual interest rate. Now, a lot of you are listening to my voice right now and thinking to themselves, what the heck is going on? So, the first thing that we should be establishing right away is that this is a finance problem. Okay, there's a couple keywords, a couple key concepts, a couple buzzwords that should be jumping out at you, and you should be telling yourself, yep, this is that one finance exercise that pretty much every paper one has. And if not in paper one, for sure in paper two. So, let's just highlight what sounds important. See, that usually tends to work out. So over here, we have these 100,000s, but these were deposited. The other thing that can help for context, although a little bit less in terms of numbers, is that it's a savings account. So this is a savings problem. In other scenarios, maybe we're in debt, stuff like that. Here, we are saving our money. So that might be relevant down the road, or for understanding better how to solve it, etc. Then they tell us that we have a nominal annual interest rate of I%. So my nominal annual interest rate is I%. And they put it in bold because it is very important, compounded monthly. At the end of the 8th year, so end 8th year, keep that in mind, end 8th year, the amount in the account had increased to 150,000. And so that is the general sort of gist of it. See? So, first I'm going to show you the formula booklet, and then I'm going to show you how you should really solve it. See? I mean, not really solve it, but what I suggest. ¿Vale? So once you establish that it's a finance problem, there are two main tools that I can show you, teach you, etc. The first one, okay, is going to be going literally straight to the formula booklet. See? So formula booklet, and what are you going to find? Within the formula booklet, you will be finding, eventually, once you look long enough, you find this compound interest formula. Okay, and this compound interest formula that I'm putting now in yellow, okay, notice it has a bunch of stuff into it, but all you really need are 5 things: the future value, the present value, the number of compounding years, the number of compounding periods per year, 1, 2, 3, 4, and 5, the nominal annual rate of interest. And so guys, for all these finance problems, you need to understand that you will be given 4 out of 5 of these, and you need to find the last one. And so within this context, for part A, you need to find the value of I. I is the nominal annual interest rate. Okay, nominal annual interest rate, nominal annual interest rate, rate of interest, yeah, same thing, see? So basically what's happening here is that they're telling you, hey, you do not have R, but you do have K. You do have K, you do have N, you do have PV, you do have FV. And so although this might look very nasty once you plug everything in, you have to realize you have 4 out of 5. And if you have 4 out of 5, you can solve it. Okay? You can solve it. You can reach R equals something, like an actual number. See what I mean? So these exercises, you always get 4 out of 5. And your 2 main tools, as I was saying, is the formula booklet or the finance app. Okay, and the finance app comes forth in your graphing calculator. Now, what do I suggest? What I suggest is that you sort of visualize and remember that in the world of finance, you are working with the formula from the formula booklet, because it's also a very, very kind reminder of, hey, if you have 4 out of 5, you can solve it. These are the things it asks for. The formula looks sort of like this. It's very useful to take that approach. But the problem is you don't always use the compound interest formula in the formula booklet. Point is, for this first strategy using the formula booklet, it's not always what you're supposed to do. There are a few scenarios where this formula is actually not enough and you have to use the finance app. So point is, The formula booklet is something you will not always have to use, okay? While the finance app always works. So, although the formula booklet might be a little bit more friendly, okay? It might be more, you know, whatever, easier to handle, easier to come across, easier to this, easier to that. In the long run, eventually you will find exercises where you need to use the finance app. So I'm not going to show you how to solve it for the formula booklet. I will show you how it works with finance app. And now, there's probably more than one of you thinking right now, like, okay, if the formula booklet doesn't always work and the finance app always works, then what are the scenarios? Yeah, what are the scenarios that make the formula booklet formula booklet. What are the scenarios that make the formula booklet not work? So the scenarios that make the formula booklet not work is whenever you have this thing that we will call PMT. And PMT, although I forget what it means, is basically going to be like any sort of monthly payment or deposit. And the main thing that's very important to understand here, that is additional to what you already pay your deposit. And notice, I haven't even entered the exercise yet, but I am giving you a lot of context of how the finance problems, how they look like in these papers, what you're going to come across, what you can expect, okay? So, the reason the finance app is something that you should prioritize over the formula booklet is because the finance app always works, while the formula booklet not always. And in which scenarios does the formula booklet not work? It doesn't work whenever you have to apply PMT. The only way in which you can apply PMT is using the graphing calculator with the finance app. Okay, what the heck is PMT? PMT is the monthly payment or deposit additional to what you already pay or deposit. Okay, and as you can see, if you just read the, like for part B, ¿cierto? If you read for part B really quickly, here at the end it says, at the end of each month, man will receive a payment of 1,000. Which is different, okay? Which is completely additional to what he already has to sort of pay or whatever, and etc. ¿Cierto? And so if you actually go to the answer key, you can see that for number 5, here are 2 variations for part A, ¿cierto? Here are 2 variations of the graphing calculator. And there's a third variation that is with the formula booklet, okay? So yes, the formula booklet does work for part A, but for part B, there isn't a version with the formula booklet because, look at that, you have PMT. So whenever you have PMT, you cannot use the formula booklet. I know this video is a little bit longer because I've been explaining a lot that context, but I think it's extremely important for us to understand that immediately. So enough blah blah, let's actually get into it from now on. See? So for part A, we need to find the value of I. So what I suggest is, of course, since we're using the finance app, get familiar with the finance app. So open up your trusty rusty calculator, make sure it's got batteries, go to apps right here in purple, press finance, it should be the only one, unless you installed Pacman or whatever, and from here, you will be using TVM solver. Okay, and TVM solver, I need you to understand, is basically like this formula in the formula booklet, but right here. And it has a variation where you can put PMT that the formula booklet doesn't have. That's pretty much it. The other thing I need to point out is that a lot of this is like easy to associate. Like PV is still PV. I% is the R that we're talking about there, ¿cierto? FV is still FV. PMT is the thing I mentioned, which for part A it just equals 0. But then you have these 2 weird things down here, ¿cierto? PY, CY, N. There's a couple different ways to answer this, and it does have to do with like periods and compounding and stuff like that. And this is n, but it's a big N, right? And so as you can see in the answer key, depending on how you approach n, and this is very, very important to understand, depending on how you approach n, it's going to change what you plug in down here. Notice, plugging in a different n changes how you plug in down there, ¿cierto? So how should I technically sort of like be answering this, or what I suggest? What I suggest is that in your calculator, see, you go for the method that is up here, ¿cierto? Prioritize the method up here. Why do I prefer the method up here? I prefer the method up here because for me, it is easier to remember that these two at the bottom are the same instead of remembering like that there's actually a difference. For me, that's easier. For other people, it's not. So I'm only going to show this strategy for the one up here. For the one up here, all you have to do is treat big N as K times N. So if big N is K times little n, then this is big N. Okay, that's the first observation I'm going to make. For me, for this method up here, ¿cierto? For this up here, you need to act, or you need to proceed saying that big N is K times little n. And the other thing you need to establish is that Py equals Cy, because they're both equal to 12, and you will treat both of them as K. And as long as you do that, you're good to go. All right, so man deposited 100,000 into a savings account. So immediately we can think, okay, it's a savings account. So initially my present value was depositing $100,000, right? And my future value, I can already establish as well. We know that it ended up being 150,000. So we can also say that it's future value 150,000. What else can we mention? We can mention that, well, the annual interest rate is actually what you're trying to find, ¿cierto? So I'm going to put this in pink so I remember this is my variable that I'm trying to find. Compounded monthly, ¿cierto? So how do you express compounded monthly over here? Well, in the formal booklet, K is the number of compounding periods per year. And so just a little bit of context, if it's monthly, how many months are in a year? 12. If it's yearly, how many years are in a year? 1. And if it's, I don't know, I mean, that's pretty much all they can ask. But maybe quarterly, you know? How many quarters are there in a year? 4. How many semesters are there in a year? 2. In my experience, it tends to be like monthly or quarterly. It doesn't go farther than that. But there are a couple variations. There you go. I know about it, but I don't know if they asked it in the IB yet. Bi-monthly, like every 2 months, would be K equals 6. See? So there you have a couple variations of compounding periods per year. Not to scare you, but those are the words you have to be familiar with. See? So compounded monthly tells me that K equals 12. And they also tell you that at the end of the 8th year. So my man deposited $100,000, which compounds monthly. And after 8 years, the amount was $150,000. After 8 years, N, the number of years. So little n is going to be 8 years, right? And as I established earlier, using the method up here, I am applying this, ¿cierto? So if I'm applying this onto my calculator, I need to calculate big N. I know that big N is K times N, ¿cierto? And you can actually pop that over here right away. You can literally put, for big N, you can put K times N. You can put 12 times 8. It'll do itself and leave it as 96. I% is actually what you're trying to find, so I'm going to leave it like that. See? And PV and FV has something interesting going on here. See? Point is, my man deposited $100,000 into a savings account. And so there's like two sort of perspectives you can take here. Okay? Just to explain a little bit the mark scheme here. You have two perspectives. So you have the perspective, POV, ¿cierto? Point of view, of my man. Or you can take the perspective point of view of like the bank. See? So if you take the I think understanding the bank is a little bit easier here. See? So if you take the perspective of the bank, initially they get $100,000. ¿Cierto? And then the bank does bank stuff, they enjoy the money, etc., whatever. And the moment that my man takes away his money, the bank proceeds to lose $150,000. So this right here is one alternative. Okay, you have a positive PV but a negative FV. While the perspective of my man, ¿cierto? Which I'm going to be putting over here with whatever purple. See? So the perspective of my man is that from his pocket, he deposited $100,000 into the savings account, ¿cierto? So initially, my man just lost $100,000. So it's a negative $100,000. And when he goes ahead and takes the money out of the bank, he earns back $150,000. So notice, in the two scenarios, you either have that PV is negative and FV is positive, or you have that PV is positive and that FV is negative. It's one or the other. You have to pick a perspective. It does not work if you leave both as positive. Okay, it's not going to work, and I'm actually going to show you. See? So you have to take these different sort of symbols. If you make them both positive, it's not going to work. I'm going to show it to you. That is why in the mark scheme over here, you have these really weird symbols. Okay? All this is really saying is that they're both either positive or negative, but because one of them is flipped, it's basically saying like, oh, okay, so if this one's positive, then the other one has to be negative. That's why it's flipped. It's like the two scenarios. See? Anyways, a lot of blah blah in this case, but probably one of my best videos explaining finance. See? A lot of context, but I'm sure some of you needed it. So now I can go ahead and plug in. I'm going to be taking the perspective of, I'll take the perspective of my man. So my man lost $100,000 initially because he put it into the bank. PMT is 0 because there isn't any additional monthly payment. And FV, the money he gets back, is positive $150,000. And this, we said we were going to treat it as K, both of them. ¿Cierto? So you go ahead and pop 12 into both. Why is it 12? It's 12 because it's compounded monthly, and K, as we said, is number of compounding periods per year. We are in this scenario right over there for part A. Yeah. And so from here, well, you plugged everything in. How do you solve for I? How do you solve for I? Solve. There's a solve button right here. And basically what's going to happen is that you're going to press that solve button and you will be telling your calculator, hey, using these parameters, all these numbers I'm putting out here, tell me how much this should be. And so you press alpha, you press enter in order to hit solve, and boom, there's the percent. So basically, if you have a big N of 96, and a PV of this, and a PMT of that, and an FV of this, and a PY and the CY of that, given all of that, your percent, your annual interest percent should be this. And if we check the mark scheme over here, it looks pretty correct to me. ¿Cierto? So for part A, that's pretty much your process. Notice that it is worth 3 points, and so if it's worth 3 points, show your work. This right here was showing my work. ¿Cierto? That is showing my work, and then you get actually it's a method point and an answer point, like plugging it in correctly or whatever, ¿cierto? And then it's a whole other point to just write down the answer. See? So I has to equal, for part A, I equals 5.07%. Actually, if you do significant figures, you count 1, 2, 3, round it up or keep it the same, you round it up. So it's actually 5.08. All right, now after all of that context, part B should be a little bit faster, see? Unless it gets incredibly hard, which we are about to find out. So we have that my man, withdraws the $150,000, okay, and places it in an annuity, earning a nominal annual interest rate of 6.1% compounded monthly. So immediately we already have a percent, we already know that it's compounded monthly, and additionally at the end of each month, my man will receive a payment of $1,000. See? So this additional sort of payment thing means I have a PMT of 1,000. I need to find the amount of money remaining in the annuity at the end of 10 years and express your answer to the nearest dollar. And so if we look over here a little bit to understand the context a little bit better, just to remember how to solve this, because I'll be honest, I didn't remember too well, but the most important part is explaining how it works, ¿cierto? So yes, I did sneak peek the answer, but I'm just trying to understand and explain it more properly. For part B, this is what's happening. Dale? Basically, for part B, yeah, it's very important that you either always go for the perspective of the person or the perspective of the bank. Dale? And in this context, for me at least, it makes a little bit more sense to take the perspective of the man, of my man. ¿Cierto? So, he withdraws the $150,000, so for a moment he earns it back into his pocket, but then immediately places it in an annuity. So, PV has to be negative. It's like, yes, it went back into his pocket for a moment, but boom, he put it back into an annuity, he lost that money. So PV equals negative 150,000. And when they tell us that we earn a nominal annual interest rate of 6.1%, so I can already establish that I percent has to equal 6.1. All right, what else can I establish? It's also compounded monthly, so K does have to be 12, and at the end of each month, my man will receive a monthly payment of 1,000. So PMT, 1,000. And because it's the perspective of my man, we have a PMT equals positive 1,000. See? Find the amount of money remaining in the annuity at the end of 10 years. Okay, this is another interesting thing. For part A, all my variables were within that initial paragraph. For part B, one of my variables was hidden in the question, or what they ask you to find. When it says 10 years right there, n equals 10. And so look at that. This is pretty much it, ¿cierto? When it says find the amount of money remaining at the annuity at the end of 10 years, that is after a while, ¿cierto? That is later on. That is in the future. So the future value is actually what you're trying to find here. See? So in this context, big N, ¿cierto? Has to be K times N. So we can say that big N has to be, actually, let me like put, I like to do this, it's a personal thing. Put 0 on everything. Just to like, well, I think here you have to put 1. Just to like start from fresh. So starting from fresh, big N has to be K times N, because we are employing the strategy up here, which is basically just this. Big N has to equal K times N. PY equals CY equals K. So big N has to be 12 times 10. This 12 times that 10. 12 times 10. I percent, they gave it to us earlier, 6.1. What else? PV, ¿cierto? PV is negative 150,000 right there, because my man lost money out of his pocket. PMT is 1,000, because my man is earning that 1,000, ¿cierto? He receives that payment of 1,000 each month. FV is actually what we're trying to find, and these last two, as we said, have to be K. See? So these last two have to be K. K is 12, so go ahead and put 12 on both. Yeah. And so from here, I can just solve for FV. So alpha, enter to hit solve. There's my value for FV. And so the amount of money remaining and the annuity at the end of the 10 years for part B has to be that number. See? So let me write that number real quick. 866.7064. Now this, ladies and gentlemen, if you box it in as your final answer, is actually not good enough. And it's not good enough because here they tell us to express your answer to the nearest dollar. And so we're expressing it to the nearest dollar. Basically, you need no decimals. And so you have to evaluate, do you round this number up or down? I mean, up or keep it the same. This is 5 or above, it's at 7, ¿cierto? So 7 is above 5, you have to round it up. That means you end up with, your final answer is 110,867. Is it dollars? Yeah. Just the dollar sign is fine. See? Boom. So that is our answer for part B. And the last thing that I forgot to mention earlier, and with this I will probably end the video, is this guy here, ¿cierto? I did tell you for part A that it has to be opposite symbols, the positive and the negative, ¿cierto? You either take the perspective of the bank or the perspective of mom man. And if you don't do it that way, you're gonna run into trouble. Let me show you how that trouble looks like, okay? Because it might happen to you the day of the test, and you do have to know how to react. So, if I were to keep them both positive, what happens? Well, you would end up with a big N of 96. I% is actually what you're trying to find. So here, I'm going to leave them both positive, ¿cierto? So this is back to the context of part A, just to show you if you leave them as both having the same symbol. And if you go ahead and solve from here, you literally, it says error, no sign change, okay? And this is happening basically because you either take the perspective of my man or you take the perspective of the bank. There is no other. What I suggest is that you pick one of them, get familiar with it, and always employ the same one, okay? All you really have to change is PV and FV. I think there are scenarios where they are the same symbol, but in my experience, almost always with one perspective over the other, you should be good to go for like all exercises. See? PMT, I always see it with end, ¿cierto? And I don't think that's going to matter to you ever. But here it does says at the end of each month. So if you really want an argument for that, there you go. See? So PMT is end because there it says at the end of each month. Ladies and gentlemen, enough blah blah. That was a long explanation, but a very needed one for some of you. So this one's for you. In my case, at least, happy Monday, and I'll see you around. Alright guys, so for number 6, we have that points A, 3, 4, as you can see, 3, 4 for point A, B, 9, 6, 9, 6, and point C, 11, 2 are shown on the following diagram. Okay, alongside the perpendicular bisectors of AB, AC, and BC. So the first thing I have to go over before I jump into part 8, B, and C is for us to understand what the heck is a perpendicular bisector. So straight to the point, let's understand that it's two words. It's perpendicular and bisector. In what context does the word perpendicular arise? Perpendicular arises when we talk about slopes. So when we talk about slopes, you either have the first version, or the most common, which is parallel slopes, and then the second version, which is perpendicular slopes. Okay, these are the special sort of slopes you can encounter. And the parallel slopes, how do they look like? It is two lines that are like right next to each other, and they never stop increasing, and also they never touch each other. And why do they never touch each other? They never touch each other because they grow at the same rate. And so if they grow at the same rate, they are never ever going to touch each other. But if they were just a little bit different, even by just a tiny little bit, something like this, you can immediately see, oh, okay, they're very similar, but one of them is growing a little bit faster than the other. And so eventually, if you extend these lines a lot, you will find that they actually do touch each other eventually. And in this poorly drawn example, you notice that they touch over here. Because in the example that I just drew, their slopes are a little bit different. for parallel lines, it is very important that we understand that parallel slopes are equal to each other. So the slope of one, I use m for slope. See, m for gradient, slope, whatever. Slope is the same as gradient. So parallel lines means that the slope of the first one, m1, has to equal the slope of the second one, m2. On the other hand, for perpendicular slopes, the fancy math sort of like equation is that the first one times the slope of the second one has to equal -1. And commonly how people remember this is really that the slope of one, if it's perpendicular to the other, means that it's going to be negative the reciprocal of the other one. See? So oftentimes we talk about, I don't know, you have a slope of 3 over 4, and this is the slope of your first line, and you know that it's perpendicular to the second one. So that means that if the slope of your first one is 3 over 4, the slope of your second one is -4 over 3. How does it look like? It looks a little bit like this. Ka-ching, ka-ching, boom, 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 right? So it's two lines that cross each other in such a way that you actually end up with a bunch of 90-degree angles, okay? So perpendicular lines look a little bit like that, while parallel lines look a little bit like this. So for us to understand this thing about perpendicular bisectors, we can immediately, let's only focus on one example. See, let's immediately focus on AB. That it? So the perpendicular bisector of AB, and I'll explain why, the perpendicular bisector of AB is this one right here. Okay, this is perpendicular bisector of AB. And it's perpendicular because, as you can see, if I were to draw a line between A and B, I end up with the 90-degree angles. And this is also a hint. If I have the slope of one of them, I can find the slope of the other one. So that's already a big hint that I'm showing you right off the start of the video, ¿cierto? And the other thing we need to understand is that, okay, so it's perpendicular, but what is this bisector thing? What's happening, ¿cierto? Guys, bisector. Bisexual, bi is for two. And sect, it's kind of like you're cutting something. See, so bisect, when you dissect a frog, for example, in science class. Actually, back in the day, I dissected a cow heart. It was kind of crazy. Point is, a bisector is something that cuts something in two. And so, how is this a perpendicular bisector? It's perpendicular because, well, it's perpendicular lines. There's 90 degrees in the middle. This has to be true as well, ¿cierto? And also because it is bisecting. If this distance here that I'm putting now in red, ¿cierto? If this distance, I'm going to make it up, see? If this distance from here to here is 3, then that means that the distance from here to here also has to be 3. That's why it's a perpendicular bisector, okay? Those distances are the same. That is the intuition of a perpendicular bisector, and the main way I think that you end up using this is because you identify the word perpendicular, and this immediately allows you to use these formulas here, ¿cierto? That the slope of one is equal to the slope of the other one times a negative and reciprocal, ¿cierto? I know that this formula is a little bit crazy, so what I suggest is that you actually memorize or learn a couple of examples. So for example, if these are perpendicular, 3 over 4, the slope of the other one has to be -4 over 3. If the slope of one is, I don't know, 1/2, then if the other one is perpendicular, it has to be -2 over 1, which is the same as just leaving it as -2, ¿cierto? Anyways, that is what's happening, okay? So now we can jump into the action. Now we're ready to face this problem because immediately you can say that, again, they tell us the perpendicular bisector of what? Of BC. So which one is the perpendicular bisector of BC? Well, between BC, it's got to be this line here, ¿cierto? So that perpendicular bisector intercepts the axis at coordinates 0, -1, which makes sense because we're talking about this point there, and 2, 0, which is this point here, ¿cierto? Also makes sense. Okay, for part A, we need to write down the equation of the perpendicular bisector of BC. So I'm just going to jump like straight into it, you guys. For part A, we need to write down the equation, ¿cierto? But the like hidden thing here is that you need to write down the equation of what? Of the perpendicular bisector. Yeah, but in its essence, you're writing down the equation of a straight line. And in the formula booklet, if you go ahead and open it, and well, I don't have it with me right now, but you will discover that within the formula booklet, if you go to the part of straight lines and etc., and I've shown this in other videos, and I know you can check it out yourself, you will encounter what we call the point slope formula or point slope form. I'm not sure. See? And this equation, for me at least, it's the only relevant one. See? The point slope formula is absolutely essential for creating lines. Okay, I know the other ones can also help you create lines, but for creating lines, I highly suggest you learn the point slope formula at its heart. How does the point slope formula look like? It looks like this. Y minus y1 equals m parentheses x minus x1. All you really need to fill in is what I'm putting now in yellow. y1, x1, and m. What the heck is x1, y1? x1, y1 is quite literally just a point, a set of coordinates. While m, as I introduced a little bit earlier, it's a slope. So what did this guy online just tell you? This guy online just told you that for you to create a straight line, all you really need is a point and a slope and the knowledge that you have to plug that in to the point slope formula. So for the perpendicular bisector of BC, they already give me 2 points, 0, -1 and 2, 0. I'm going to go with 2, 0 because why not keep things positive? Mindset and perspective is your life at the end of the day. See? So I will be choosing 2, 0. Got it? However, I also need the slope, right? And so how can I get the slope from here? Well, again, from your formula booklet, you will discover that you have the, I think they call it the gradient formula. It's also in your formula booklet. Remember that the gradient is the same as slope. And the gradient formula, you should recognize it as m equals y2 minus y1 divided by x2 minus x1. So in this case, instead of needing 1 point, here you actually need 2 points. The moment, and here's the other big brain play you can sort of think, the moment that you have 2 points, that means you can get the slope. And so if you have 2 points and you get the slope, well, you can spend one of those points for plugging it over here and get a line. So what is this whole like logical implication giving you? Is that if you have 2 points, you can create a line. Because from these 2 points, you get the slope. And one of those points will be your point that you plug into the point slope formula. I just said point like 20 times in 2 seconds. That was pretty exciting. Anyways. So how do I get the slope from here? Well, you need to plug in those 2 points, ¿cierto? And you define which one is your first and which one is your second, see? And so intuitively, it makes more sense for this one on the left to be my first, just because it shows up first. So if this is x1, the 0, then that has to mean that this -1 is y1. In other words, this 2 has to be x2, and this 0 has to be y2. Okay, as long as you're organized and plugging in, you're gonna get these points easily. See? So my slope, now like actually plugging in for part A, my slope has to be y2, which is 0, minus y1, which is -1, divided by x2, which is 2, minus x1, which is 0. So notice how I plugged it in parentheses, just so that I don't mess up the double negatives. So up top in the numerator, I end up with +1, and on the bottom I end up with 2. See? So the slope for my equation for part A is 1/2. See? Now, for part A, they're still asking for the equation of the perpendicular bisector. So I just found the slope. So ta-da! And now I need to find a point to plug into the point slope form, and I will be choosing to plug in this guy here. See? So boom, I have my point. Boom, I have my slope. I just need to plug in into the point slope formula. So let me give or make a little bit of space up here. So the point slope formula was y minus y1 equals m parentheses x minus x1. All right, cool. What did I discover? That m is 1/2, and that one of the points that I can plug in is 2, 0. And so if I plug everything into my point slope formula, I end up with y minus 0, because this is y1, this is x1, ¿cierto? y1 is 0, x1 is 2, equals my slope for m, 1/2, parentheses x minus 2. So y minus 0 is of course 0. This 1/2 is going to go ahead and distribute. So that means I end up with x divided by 2 minus 1/2 times negative 2. You can check with your calculator, but you should end up with negative 1. Okay? So here is my equation for the perpendicular bisector of BC. I don't know why I was writing A. So for part A, here it is. And if you don't trust me, well, it's about time that you do. Here it is. There's the negative 1. And here they put 0.5 times x, which is the same as saying 1/2 times x, which is the same as saying x divided by 2. So all of this is the same. You can put it as decimal, leave it as fraction, whatever you want. See? That is for part A. Then we discover, or actually not discover, but then they tell us, right, that for part B, the equation of the perpendicular bisector of AB is this. And so AB, which will now be putting in green, it's whatever is the perpendicular bisector between A and B. And so between A and B, it makes more sense that it's this guy here. ¿Cierto? So the equation of this guy is y equals negative 3x plus 23. And on the other hand, right, we have that the equation we just discovered for part A is that y equals negative 1/2 x minus 1. Sorry, positive 1/2 x minus 1. Talking about this guy here, by the way. See? Just going to rewrite it. Probably makes more sense to most of us if I leave it like this. See? It's the same thing. Yeah, so those are the two equations I have. That is the information that I have at hand. And for part B, you need to find the coordinates of point V. Point V, which I am now putting in red, is this guy here. So find the coordinates of point B where the perpendicular bisectors meet. Give your answer to, let's not forget that, to 4 significant figures. So you guys, think about it this way. They're telling us to find point V. And they tell us that point V is exactly where the perpendicular bisectors meet. So if it's where they meet, it's where they intersect. And here's the big brain play. If it's where they intersect, it's where they are equal to each other. Ladies and gentlemen, whenever two lines intersect each other, then that means those two lines at that point are equal to each other. And why would they be equal to each other? Because they would share the same x and y values. They share the same x and y values right where they intersect. And so that means that they have to be equal to each other. So think about it this way. If this is my line 1 and this is my line 2, and they tell me, apparently they meet, they intersect, they are equal to each other, and find the coordinates of that. See? So you're going to go ahead and take line 1 and equal it to line 2, quite literally. And if you go ahead and take line 1 and equal it to line 2, then that means, well, think about it. How can you make them equal to each other? Well, they both have a y on this end, ¿cierto? So think about it this way. You can have like a y equals y, and I know this is kind of weird, but you can have a y equals y, ¿cierto? And this y is going to be from line 1, and this other y is going to be from line 2. And so the y from line 1 is this whole thing, negative 3x plus 23. And the y of line 2 is this whole thing, which is 1/2 x minus 1. And although this looks kind of weird and kind of nasty, think about it. How many variables do you have right here? You only have x. Yes, there's one on the right. Yes, there's one on the left. But from here, you can find x equals something, okay? But the more important big brain play that I really need you to understand for the day of the test is that when lines meet or when they intersect, they are equal to each other. So go ahead and equal those lines. That's all you gotta do. All right, let's get to it. So from here, you gotta get x, ¿cierto? So throw everything to one side, then everything to the other side and see what happens. So in this context, I'm gonna choose to have all my x's on the right side. So that means I gotta do, for example, I don't know, plus 3x to both sides. So that means I end up with 23 equals 3x plus 1/2 x is gonna give me 3.5x minus 1. And from here you want to get x alone, so you go ahead and do plus 1 to both sides. That means you end up with 24 equals 3.5x. So from here you want to solve for x, divide both sides by 3.5 in order to get x alone. So x has to equal 24 divided by 3.5. Now I need to go get my calculator, so give me a second. So from here, we can go ahead and do 24 divided by 3.5. 24 divided by 3.5 will be giving me that. So x equals 6.857. 142. Now, from here, right, I just found the x value, ¿cierto? So the x value that I just found for point V is exactly that. It's 6.857 blah 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 blah, ¿cierto? Now, if you want to find your value for y, all you have to do, because they intersect here, is that you gotta take that x value, ¿cierto? And plug it in either in line 2 or in line 1. And they will both give you the corresponding y value, okay? Because they meet here, they both have to give you that answer, ¿cierto? So I'm gonna go ahead and plug it in. I don't think it really matters. I'll plug it into line 1, see? So if I plug it into line 1, that means I have -3 times my value of x, which is this guy here, ¿cierto? Close parentheses, plus 23. And so from there, your value for y has to be 2.42 8571. ¿Cierto? All right. Now we're almost done here. See, the last little bit of challenge that is missing for part B is that we need to give our answer to 4 significant figures. So guys, for 4 significant figures, all you have to do is the following: write out the entire number as is, and you will count 1, 2, 3, 4. And on your 4th number, because in this case 4 significant figures, look at the number to its right and see if you round it up or keep it the same. In this case, the number to the right is not 5 or above, it's 4 or below, and so we actually keep it the same. So for 4 significant figures, for x, we're going to leave it as 6.857, okay? That is a very weird 8. Let me draw it again. There we go. See? Well, for y, we do the same thing. We count 1, 2, 3, 4. Do we round it up or keep it the same? You round it up, because right next to it you have a 5. So you're going to go ahead and round it up, and you end up with y equals 2.429. And if we go ahead and check our answers, let's hope I'm right. It looks to me like I'm right. So right here, the 6.857 and the 2.429 are right over here. See? So that is my value for x, that is my value for y. Technically, these are the coordinates of point V. If you want to do like the mega final answer and get really fancy, I'm pretty sure this gives you full credit, but anyways, technically the coordinates for point V would be to write it out as is, ¿cierto? So you should be doing something a little bit like that. See? All right, there we go. So that would be for part B. And last but not least, the weirdest part mainly because it has to do with understanding how a Voronoi diagram works. It has to do with the following, ¿cierto? So they tell us that a Voronoi diagram is constructed with points A, B, and C as the 3 sites. And we need to draw, for part C clearly, the edges of the Voronoi diagram on the given diagram. So what the heck even is a Voronoi diagram? Guys, this is actually a very cool exercise because it forces you to really understand how a Voronoi diagram works. And I think it's worth listening to the monologue you're about here because it's going to help you also understand why perpendicular bisectors are a thing within the world of Voronoi diagrams. So, when do people use Voronoi diagrams in real life? They might use it for, like, I don't know, building schools, okay? Because you don't want to have like one region filled with 10 schools and the one right next to it filled with 2 schools. You want them to be spread out evenly. You want them to be spread out evenly. You want the space between them to be equal to each other, okay? And so a lot of times for like building cities and stuff like that, a Voronoi diagram would make like a lot of sense, ¿cierto? So it's mainly used for spacing and stuff like that. So imagine points A, B, and C are all like schools, right? And maybe this is whatever, like kilometers, right? And so you're trying to see where to put the schools, and someone defined, it has to be at sites A, B, and C, ¿cierto? And sort of like the proof that happens from there is the perpendicular bisectors that arise from those sites, ¿cierto? So you define the sites, then you define the perpendicular bisectors, and voila, there you have your Voronoi diagram, basically. See? Point is, here you have a bunch of lines, ¿cierto? And so they tell you to draw clearly the edges of the Voronoi diagram. And so there's a couple right answers, a couple wrong answers. I mean, there's one right answer, ¿cierto? But what a lot of people would maybe eyeball and get wrong is if they say like, oh, okay, so the edges of my Voronoi diagram are maybe like this, and then like that, and then like this. See? And they don't really know why. They just kind of eyeball it, they go with it. And that is what I mean, that listening to this monologue will help you understand what is the right way to do it. ¿Cierto? So this is the wrong way to do it because you're kind of like eyeballing it. ¿Cierto? The thing is, even if I were to draw in the bisectors that I mentioned, so the bisector AB is this, the bisector AC is this, ¿cierto? And the bisector BC is this, you can't draw all of it in because a Voronoi diagram has to be split up evenly, and this wouldn't be even, ¿cierto? In fact, this might be even if I have like a point D over here, but I don't, ¿cierto? All this space here is kind of like left there lying in space. It doesn't make sense. And so what does make sense? See? Let's get to the point. What would make sense, ¿cierto? Or actually, I think it's better to understand that what doesn't make sense, ¿cierto? If I include this line here, ¿cierto? Here's the thing. If I include that line right there, if I were to include this line as an edge, you have to ask yourself immediately, okay, this is pretty much a line that is gonna be an edge between A and B, ¿cierto? And so if this is the edge between A and B, is the distance from here to here same as the distance from here to here? Clearly it's not, ¿cierto? Is the distance from, I don't know, like here to here, same as from here to here? Not really, right? You're off by a little bit. And so that is how you have to like imagine it or think about it, ¿cierto? You could prove it mathematically, but for part C, you can just eyeball it. See, they don't ask you to prove it. And so from here, ¿cierto? So this is the bisector between A and B, ¿cierto? And if I include this entire line as an edge, it partly makes sense because from here to here is the same as from here to here. And notice, even counting like these red dotted lines, you can sort of see that it's 3 squares. And from here to there, it's also going to be 3 squares. And so that is a way in which you can actually eyeball or make an educated guess, ¿cierto? So that is an edge that we have to include, the one that is up here, ¿cierto? That is an edge that we have to include, but do we have to include the edge that's down there, ¿cierto? The edge that's down here doesn't make too much sense because from here to here, is it the same from there to there? Nuh-uh. And so in this scenario, the edge we have to choose for the bottom so that A and C are at a similar length is actually this edge right there. And here we can do the same sort of like logical, like maybe approach if we want to think about it, ¿cierto? From here to here, ¿cierto? It's pretty close from there to there. If you calculate that distance, it will be equal to each other, ¿cierto? Eyeballing in this scenario is a little bit harder, but I think the explanation of how it works is much more important, ¿cierto? So that would be your other edge. And your last edge, ¿cierto? Would have to be between this and this, ¿cierto? So notice, this guy on the top left is the perpendicular bisector of AB. This guy on the right is the perpendicular bisector of BC. And this guy on the bottom is part of the perpendicular bisector of AC. What's important when you pick your edges is that you pick, like for example, the entire perpendicular bisector of AC is this entire line, but I only picked as an edge half of it. And the same for BC. The perpendicular bisector of BC is this entire line, but the edge will only be half of it. Okay? So, again, this is sort of like an eyeballing thing. What I suggest though is that you redraw those perpendicular bisectors and you keep in mind you usually only keep half of it, ¿cierto? If you keep the whole line, it's not gonna work like entirely, ¿cierto? So only take the half that for you helps. See? Again, the perpendicular bisector of AB is very, very useful for this part here, but you don't need the perpendicular bisector for AB down there. You don't care about the part down here, so don't include it as your edge. See? Okay, I think near the end I was a little bit more clear on how the edges work. It's a little bit hard to explain, but I tried my best. And also, this is a very, very particular question for the AB. I don't usually see that they ask you to draw the edges of a Voronoi diagram, but today they did. See? So ladies and gentlemen, that is for number 6. And just so you believe me, there's the answer as well. Alright, you guys, so for number 7, we have that the following graph shows the depth of water d meters in a river at t hours after 12. So t is for time, and it will be after 12. So if t equals 1, just so that we're all on the same page, if t equals 1, then that means we are at 12 o'clock plus 1 hour, 1 o'clock, ¿cierto? If we have t equals 2, that means it's going to be 12 o'clock plus 2, so that's 1400 hours, which is 2 o'clock. Okay? All right, cool. Then they give us a bunch of information, which I will help you organize a little bit. So we have that at 3 o'clock, here, so at 1500 hours, the depth of water reaches 7 meters, which is its highest level. And later on, they mentioned that at 9 o'clock, 2100 hours, the depth of water drops to 1 meter, which is considered its lowest level. So the depth can be modeled by the function blah 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 blah. Now, this blah 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 that we just went over should be familiar. Okay, you should recognize this at least a little bit. And so this blah blah blah, you notice that it has a sign inside of it. It has an A outside, a B in the parentheses, a plus something outside, etc., etc. We're dealing with a sinusoidal function. Now, a couple things. First of all, I probably wrote that incorrectly. Second of all, I don't really care. Third of all, what you need to have very clear is that you need to be able to identify these exercises. Once you see that you're dealing with a sign that has letters outside, inside, outside, ¿cierto? And you're dealing with something that literally looks like a wave, then you should be thinking, we're dealing with a sinusoidal function problem, a wave problem, a sine problem. That should be coming to mind. And it should be coming to mind because the context of this problem, the context of what A means, what B means, and what this plus 4 means is absolutely essential for you to be able to solve parts A, B, and C. So before even talking about parts A, B, and C, I will spend some time explaining what A is, what B is, what this plus 4 is, okay? And guys, this is a pattern that always repeats. whatever is multiplying the sign on the outside, usually in front of it, and they tend to call it A, is what we will call A for amplitude. For now, I just need you to hear these words. Later on, I will explain what they're for. See? This B that was multiplying my variable inside of the parentheses, careful, multiplying my variable inside of the parentheses, it's not exactly the period, but it's for the period. And I know that that's a little bit troll, but for now, deal with it, okay? It's for the period. Yeah. And this plus 4, which is completely on the outside, ¿cierto? It's adding on to the sign, but on the outside, ¿cierto? It's what we call the vertical shift. All right. Now, you've probably heard the word amplitude, period, shift, and all that stuff, but now let me give you more of an intuitive definition. See? So, up here, I wrote in more intuitive terms how I like to remember these terms. So on the one hand, we have period over here, which I call the distance from max to max or min to min. Why do I call it this? Because the sine wave is literally a wave. It's never ending. It always repeats. And as you can notice, you have a bunch of different maximums. So all of these in pink are going to be maximums. That it? And all of these in, I don't know, whatever green are going to be minimums. That it? And so the period, you can think about it a little bit like, I don't know, it's like an entire loop, okay? That's a good way to remember it. It's like an entire loop throughout your sine function, ¿cierto? Because you can take the picture of the sine function over here, and that picture right there is the same as this picture right here, see? It repeats, the sine function repeats. And so there's a lot of different periods here, and you just have to find it once in one place, and you find it once everywhere, okay? Everything everywhere all at once. Point is, if you want to find the period, it's going to be the distance between this and this, or it's going to be the distance between this and this, okay? Either of them works. That is how you find the period. The vertical shift is the line through the middle. So if you take your function and you draw a line quite literally through the middle, which in this case would look a little bit like this, that's going to be your vertical shift, okay? Why is the vertical shift useful? It's useful because it helps you find the amplitude. The amplitude will be from the line in the middle, which is the vertical shift, to a max, or from the line in the middle to a min. So the amplitude is, for example, from here to here, okay? That would be your amplitude, which is the same as saying from here to here. That's also your amplitude. This is not drawn to scale. It's not drawn nicely. I'm not an art teacher. But you will understand that all these different values for amplitude are exactly the same, okay? From the middle to the max or from the middle to a min, all these values are the same. If it's 3 in one of these, it's 3 in all of these, okay? Yeah, and the last thing I have to sort of go over, although it's something that in this exercise does not show up, and in my experience, it usually doesn't show up, is the phase shift, okay? All your functions have what we call a vertical shift, which is for your y values. So it's how much your function goes up or down. So y values, it's a horribly drawn y, but it's a y. And the phase shift is actually going to be for your x values, okay? So oftentimes they call it like the distance from the origin, from the 0, 0. But really, it's just how it moves to the left and to the right, see? Because if I were to take this function and move it a little bit to the right, then maybe instead of starting there, it would be starting here. Okay, and the function would be like the same, ¿cierto? Just that it starts a little bit more to the right. So here my phase shift would be, I don't know, like x equals 2 or something, see? So that is what we mean by phase shift, okay? Where does the phase shift go? The phase shift goes inside the parentheses. That is, so in this context, my phase shift technically is bt plus 0, ¿cierto? That's how we end up with this over there, because the 0 turns to nothing. My phase shift in this case is just 0. So for moving from left to right in your x values, it will be whatever is adding or subtracting within the parentheses. The vertical shift is whatever is adding or subtracting outside the parentheses. See? And now that I did this whole introduction, I can finally go ahead and jump into part A. Find the value of A. A in this case, as we said, was going to be amplitude. Amplitude, as we mentioned, is from the line in the middle to a max, or from the line in the middle to a min. The line in the middle, what the heck was it? Is the vertical shift. The vertical shift is whatever is adding or subtracting on the outside of my parentheses. On the outside of my parentheses. So boom, I can already draw my vertical shift like this. So here I have a y equals 4. ¿Cierto? Yeah. So that means that my amplitude visually goes from this line in the middle up to a maximum, and also from this line in the middle to a minimum. Now some of you are probably already thinking, okay, how does he know that it's exactly there? Why isn't it like, I don't know, here or there? Like, why is it exactly there? Yeah, it's exactly there because, as I mentioned, and this is very important, the amplitude is from the line in the middle to a maximum or to a minimum. Now, how do I know that exactly there I have a maximum and exactly there I have a minimum? Because earlier, and this is a good test-taking skill, the IB always gives you information that you end up using. Okay, it's very weird for the IB to give you something that you do not end up using. Okay, so good test-taking skills, whatever they give you is probably useful. Earlier, they told us this. ¿Cierto? So, this first piece of information that at 3 o'clock the depth of the water reaches 7, which is the highest level. So the highest level means I'm dealing with a maximum, which is at 3 o'clock with 7 meters. 3 o'clock is 3 hours after 12, so my maximum is at 3,7, which makes a lot of sense. 3 and 7. So this maximum right here is 3,7. While at 9 o'clock, the depth of the water drops to 1 meter, which is its lowest level. Lowest level, we're dealing with a minimum. 9 o'clock, that's how many hours from 12? It's 9. 12 plus 9 gives you 21. So 9,1 will be my lowest level. Here is the minimum that I'm dealing with. 9,1, here's the 9, here's the 1. Pretty straightforward, isn't it? So the value of A is the amplitude, which is from the line in the middle to the max, or from the line in the middle to a min. And now you have all the information you need, because the line in the middle is y equals 4. ¿Cierto? So that means from here to here, it's going to be 7 minus 4, which gives you 3. So the amplitude for A has to be 3. And if you want to calculate it with the minimum, it's a very similar process. You just have to do 4 minus 1, gives you 3. Okay, so either of these work. You can do it from the max or from the min. I feel like it's more intuitive to do it from the max, but to each their own. See, point is, the concept here is what matters the most. See, you have the vertical shift, you have the line that runs through the middle. The amplitude is from that to a maximum or from that to minimum. The value is the same. So A equals 3, amplitude equals 3. That is for part A. For part B, we need to find the value of B. ¿Cierto? Now, the value of B is not the period itself, but it's for the period, okay? And here is a very fancy sort of equation that we have to remember that I'm pretty sure is not in your formula booklet. I'm gonna double check, but as far as I know, I don't think it's here. Yeah, no, I don't think it's here. See, I've checked it a couple, I think I would remember, see? I don't think it's in your formula booklet. I'm gonna show you the answer key just so that you trust me. Not that you should trust guys online, but in terms of math, you can trust this guy at least. And here you can see that this is the key equation, okay? The key equation is that 360 divided by B has to equal your period, okay? So if you find what your period is, for example, in this case, they somehow found, and I'll tell you how, but they somehow found that period equals 12, then that means you have 360 divided by B equals 12, and you can find B from here, see? Yes, it's in the denominator, but it's your only variable, so you can get B from here, that it? So, two main things, ¿cierto? The first one is that you have to know this formula, see? 360 divided by B equals your period. That's why earlier I said that B is for the period. It's not that it's the period, it's for the period because you gotta plug it into this equation right there. Okay, that being said, how the heck did they find the period? I said earlier that the period is the distance from max to max or min to min. And here, I don't have another max. and I don't have another min. There's only one max and there's one min. So what the heck do you do? Well, cool bit of information here. Because this is a pattern that always repeats, something that you eventually notice, and I'm going to tell you right away, is that, oh, okay, if this right here is my period that I put in red, ¿cierto? Which goes from max to max, technically this period, what it's doing is that it goes from max to min, and then it goes from min to max. And the same down here. If I'm thinking of a period that goes from min to min, it goes from min to my max once, and then from my min to my max again. So, what I'm basically trying to tell you is that if I were to put values here, for example, the distance from, if my period, if literally my period is, I don't know, I'm going to make it up, okay, it's 30. Now, if my period equals 30, then that means that the distance from max to max is 30. Okay, cool. But that also means that the distance from my max to my min has to be 15, and from my min to my max has to be another 15. 15 plus 15, 30. So what we're going to do here is find the distance from my max to my min and multiply it by 2. What is the distance from my max to my min? The distance from my max to my min, notice how it goes from 3 over to 9. So that means that over here, I'm just going to be, just to be very, very visual, I go from 1, 2, 3, 4, 5, 6. From 3 to 9, I have 6. So that means that basically for part B, ¿cierto? Max to min is 6. So that means that my period is 2 times that. It's going to be 6 times 2. That gives you 12. So your period has to be 12. Okay? Cool. So now that you found that your period is 12, you apply the formula that I told you earlier, which is 360 divided by B equals your period. I just found the period, which is 12, so 360 divided by B has to equal 12. From here, what I like to do is get rid of fractions because, let's be honest, nobody likes fractions. Multiply both sides by B. This goes away with this. 360 equals 12B. Go ahead and divide by 12, divide by 12. You end up with B equals 30. And just so that you guys believe me a little bit more than yesterday, we can have here that 360 divided by 12 is going to be that 30, and it's also over there. ¿Cierto? Bada bim, bada boom. For part B, that is the value of B. See? I think the biggest confusion that at least I used to have back in my day was that I didn't have very clear that B, it's not that it's the period, it's for the period. It is very, very essential that you understand the distinction, and the best way to remember that is actually to remember this formula right there. See? In case anyone is a little bit confused why it's 360 and not 2 pi, that's because this is the approach in degrees, okay? And if you were to be doing the approach in radians, it would be that, see? So for radians, it's 2 pi divided by B equals period. For us, since we're doing it in degrees, it's 360 divided by B. ¿Vale? I'm not going to get into radians because why would I? But just so you know, see? That is the formula. Stick to this one. That's my suggestion, especially if you're AISL. If you're AASL, this story might be a little bit different. Yeah. Last but not least, for part C, we need to find the first time after 12 when the depth is equal to 3. Equal to 3, and give your answer to the nearest minute. Now notice, it says the first time after 12 when the depth is equal to 3. Which makes sense because if I were to take my graph over here, for example, and I say, okay, so here I have time equals 3. Oh, sorry, here I have depth equals 3. ¿Cierto? So if you go ahead and do depth equals 3, if this is 4, then 3 is going to be a little bit under it. ¿Cierto? And how many times am I cutting through my graph? Dude, I'm cutting here, 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 here. I'm cutting a bunch of times. ¿Cierto? So which intersect do they want? They only want the first one. Okay, they only care about the first time after 12 when the depth is equal to 3 meters. Give your answer to the nearest minute. Okay, so after 12. This function is already in terms of after 12. See? So anything to the right of this is after 12. In fact, if I were to put time down on the bottom, this is 12 o'clock. This is 1300 hours. And back here is 1100 hours. See? At a -1. ¿Vale? So technically, it's anywhere in this graph that I'm watching right now where it's equal to 3. So depth equal to 3 meters. Depth is my distance. My depth is depth is my y value. ¿Cierto? It's d meters. See? So that means that I can put y equals 3 over here. That's basically what I'm trying to tell you. So you put y equals 3. That means I'm drawing a line like this. And that is what I'm trying to find. Boom. The first time after 12 o'clock when the depth is equal to 3 meters, which is going to be a little less than 7. ¿Cierto? So a little less than 12 plus 7, a little less than 7 o'clock, actually, unironically. See? Yeah, so that is the intersection that we're trying to find. See? Now, there's a couple different ways to do this. I'm not sure which one to show, actually. Calculator or by hand? What do I do? I'll show you by hand because I think it's more useful for other problems as well. See? So if we were to solve this by hand, this is what happens. Basically, we put y equals 3, ¿cierto? And here's the thing. You're trying to find the time, so you don't know your x value, see? And they gave you a y equals 3. So basically, this is the key information. What is your x when y equals 3? So if y equals 3, then this whole thing equals 3, ¿cierto? So that is 3 equals a, which we called 3 from part A, times sine, parentheses, b times t. B we found was 30. I don't think I wrote that anywhere actually, but it's something I know. B equals 30. So here we have parentheses 30t. And then way on the outside we have plus 4. See? Yeah. So basically all I did was plug in this information. What is my x when y equals 3? Knowing that a is 3, that b is 30, and that this whole thing is 3. ¿Cierto? That's pretty much what I did. Okay, so I plugged that in. It's down here, and the x that I'm trying to find the first time is right there. So I need to get that variable alone. I need to get that t alone, which I know is very spooky right now, and which is why I wanted to show it by hand, because it's useful to know how to approach this. See, you can always just graph with your calculator and forget about it, but I also think it's worth knowing sort of like what to do in these scenarios. See? So what do you do in these scenarios? Well, it's inside of a parentheses of a sine. So you want to get sine alone first. See, so for getting this sine alone first, what I can do is do -4 to both sides. That means I end up with -1 equals 3 sine, parentheses 30t. And from here, to keep getting sine alone, I can divide both sides by 3. So that means I end up with sine of 30t equaling -1 over 3. See? So what the heck do you do from here? Well, think about it this way. If this exercise were something like this, come on, I don't know, 2x equals 4, see? And I tell you, get x alone, what do? You divide it by 2, it's very obvious, see? And you end up with x equals 2. Now, why do you divide by 2? You divide by 2 because right here, you have 2 times x. And so what is the inverse operation of multiplying? Dividing. That's why you divide by 2. It's the inverse operation of x. Here you have to do the same question. What is the inverse operation of sine? Sine inverse to both sides is what's going to get you the answer. So basically, following the example I gave you, see? When you have 2x equals 4, 2 times x equals 4, you divide by 2 because division is the inverse operation of multiplication. Makes sense. And the inverse operation of sine is sine inverse. So what does the sine inverse do in this context? It makes this go away with this, and you only end up, very nicely, with what is inside of the parentheses. You only end up with the 30t equaling sine inverse of that whole thing. Now, sine inverse of that whole thing, very exciting. You take out your calculator. You hope it works. okay, you want to make sure that your mode is in degrees, okay? I guess you could answer in radians, but we're gonna answer in degrees. And you just go ahead and do sine inverse. So you're gonna press that blue button on top of sine. So second sine, there's my sine inverse. For a fraction, I like to do alpha y equals and press the first one. It's just a habit, ¿cierto? So -1 divided by 3, close the parentheses, sine inverse equals whatever that is. See, so 30t equals -19.471. Actually, let's put the whole number. Since we're going for the nearest minute, let's just put the whole number and then see what happens, okay? This we divide by 30 in order to get t alone. So t has to equal this divided by 30, -0.6490. All right, and from here you can see that we got an answer that's a little bit weird. It's pretty questionable, like what's going on, ¿cierto? So you just found t equals -0.6490, ¿cierto? And so what's happening right now, and you have to be very creative for this, so get ready, is that technically at t equals -0.6490, it's like somewhere here, right? And so what do we have somewhere here? Well, the sine function is something that repeats all the time to the right and all the time to the left. So over here you have a sine function that keeps going a little bit like this, ¿cierto? So, okay, that's what's happened. That's what's happening, right? So you plugged into your equation, ¿cierto? You found the value for t, and you found this intersection, right? Whether you like it or not, that is intersection that you found. So how do you solve it from here? Well, the main idea is the following. Basically, ¿cierto? Basically what's happening is that this 0.6490 is right there, ¿cierto? This distance is 0.6490. And also, this distance from 0 to -1, ¿cierto? Is 0.6490. But since we're smart and we understand how the sine function works and it repeats over time and etc., all you have to do is understand that, okay, so this point right here has to be 6 plus this. So this point here is actually going to be 6 plus 0.6490. It's going to be 6.6490, comma 3, because we are talking about y equals 3 here, ¿cierto? So that is a little bit of a tougher sort of interpretation, but I think a wise way to go about it is that if you get this value -0.6490, put it in your graph. You do have to draw the graph a little bit, and that context might help you figure out to say, okay, so basically when you plug it in terms of math, you don't know which intersect you're getting. I got this one, and so if we're looking for the one after 12, you got to do that plus 6, ¿cierto? And again, this is very, very visual, the approach, but it's also completely valid. So t in this case has to end up being this. So that is the value for t that we're going for. T equals 6.6490. And this to the nearest minute is a whole other adventure. This to the nearest minute is a whole other adventure. Basically, what we have to understand is that in terms of time, ¿cierto? This 6 is my hours, ¿cierto? So it's 6 hours. And this 0.6490 is basically minutes, but in terms of hours, ¿cierto? So if you want to bring that in terms of hours, well, how many minutes are in an hour? 60. So if you do 60 times that 0.6490, notice that we end up with 38.94. So that means that this 0.6490 that is like in the decimal part is simply 38.94 minutes, which is the same as saying to the nearest minute, ¿cierto? To the nearest minute, it's the same as saying 39 minutes. So really, the time that we're dealing with is 6 hours and 39 minutes after 12. So that has to be at 1800 hours with 39 minutes, which is the same as saying 6 with 39 p.m., which is exactly what shows up on my answer key. See? So ladies and gentlemen, the sinusoidal problem is definitely a tough one. But the cool thing about it, or at least what I think, is that it's very repetitive. It's a very repetitive procedure. There's not too many new things they can ask you. As long as you understand amplitude, and that A is the amplitude, that B is for the period, and the thing outside is the vertical shift, you should be able to figure everything out. Don't forget this formula. It is absolutely essential for solving these problems. Okay? And this thing for part C, yes, it was tougher. Yes, it had some creative thinking. But now that you went over it, if it shows up on the test, you're going to nail it. So trust yourself. That is for number 7. Alright, guys, number 8 is not that hard, but it does have a big brain part near part B. Not it. So for now, let's just jump into it and understand how and what we have to do. We have that the formula F equals 1.8 times C plus 32 is used to convert a temperature in degrees Celsius, C, to degrees Fahrenheit. Makes sense. You plug in, I don't know, C equals 1, and you end up with F equals something. In this case, you end up with F equals 33.8. Okay, so you plug in a Celsius, it gives you a Fahrenheit. Fair game. For part A, part I, we need to find the formula for converting a temperature in degrees Fahrenheit to degrees Celsius. So read carefully. Initially, what we had was a formula that would help us convert from Celsius to degrees Fahrenheit. And here, we need something that converts Fahrenheit to degrees Celsius. So notice, in the context of converting from Celsius C to degrees Fahrenheit, you have F equals something something C. And so if we want to go from Fahrenheit to degrees Celsius, that means we need to find C equals something something F. When I say something something, it's going to be the 1.8, the plus 32, all that stuff. See? So for part AI, the formula we start with is F equals 1.8 times C plus 32. And we basically want to reach a formula where C is alone. So getting C alone from here is fairly simple. Subtract both sides by 32. F minus 32 equals 1.8C. And to keep getting C alone, you can divide by 1.8 to both sides. So C has to equal, actually, I'm probably just going to leave it like that. So F minus 32 divided by 1.8. See, that's probably good enough. As we can see over here, there it is. See, F minus 32 divided by 1.8. So that is for part AI. For part A double I, what we encounter is that we need to find the temperature in degrees Celsius that is recorded as 77 degrees Fahrenheit. So, essentially, again, read slowly, define your terms with care. Over here, you need to find, what do you need to find? Celsius. Okay? You can basically cross off everything else. Find Celsius. 77 Fahrenheit. That's literally all you need. Find Celsius, 77 Fahrenheit. So what is C if my Fahrenheit is 77? That's what it's asking you to find. See? That is what you need to do. And technically from here, just so you know, or just to open up your mind a little bit, you can plug in either in this formula there, the one we started with, or the one down here. They will both give you the answer. It doesn't matter. But in the world of IB, if you have something like if you have an exercise with parts like AI and A double I, they're usually very related to each other. See? So part A double I, it's not that you need part AI, but it's much easier with part AI. See? Usually these exercises with parts are very, very related, and they can be a big hint on how to move forward. In this case, this is literally all you need. So I'm going to plug that information down here. And so for part A double I, C is something you don't know, so you leave C as C. And Fahrenheit F is going to be 77. So C equals 77 minus 32 divided by 1.8. Now, we have our trusty rusty calculator, so we can go ahead, make sure it has batteries, unlike mine. Okay. And I like to put a fraction for these. See, so you can use alpha, y equals, press the first one. You pull out a fraction, you do 77 minus 32 whoops, 77 minus 32, and there we go. Divided by 1.8. Go ahead and press enter, pray that it works. 25. So C equals 25 when Fahrenheit equals 77. See? There you go. Yep. And now it starts to get a little bit more juicy. See? Then they tell us that over 1 year, the mean daily temperature in Mexico City was calculated to be 70 degrees Celsius with a standard deviation of 9 degrees Celsius. No one likes statistics, and people like even less standard deviation. But gotta do what you gotta do. Here we are. See? So the mean is 17 degrees Celsius, while the standard deviation is 9 degrees Celsius. That is basically the information that they're giving us. And so for part AI, all of this, careful, in Fahrenheit, find the mean daily temperature. So part BI is a little bit more friendly. Basically what they're giving us this time is that you have Celsius equals 17 and you don't know what Fahrenheit is. That's what you're trying to find. See? So they ask you to find the mean daily temperature in Mexico City in degrees Fahrenheit, and they give us 17 degrees Celsius right here. So that means we have C equals 17. You don't know F, find it. ¿Cierto? So in this case, am I better off plugging into this equation here or that equation there? They both work, but it makes a little bit more sense if I plug it into the first one, because in the first one, F is alone, so solving is going to be slightly easier. See? It's not that it's wrong if you use the other one, it's just a thing of like what's easier. See? So, the formula up top is F equals 1.8 C plus 32. So if you go ahead and plug in 17 here, it's 1.8 times 17 plus 32. Put all of that into your calculator, it should look like this. 18 times 17 plus that 32. Yeah. So Fahrenheit, in this case, give me a really big number. Is that okay? Oh, I put 18. All right. I'm very glad that happened because first of all, it can happen to anyone, but also you can constantly be checking your work by questioning your numbers a little bit. See? Of course, you have to trust the process, but hey, we all plug in sometimes incorrectly into the calculator. It just happened to me. It can happen to you. It can happen to anyone. See? So if you end up with a really big number right when before I got an answer of 25, yeah, you're probably off by a little bit. See? So there I plugged in again. Bada bing, bada boom. Fahrenheit in this case is 62.6. And over here, it's right there. Yeah. So that is for part BI. And for part BII, we have that the standard deviation of the daily temperature in Mexico City is something that we have to find. See? So for part BII, what a lot of people would do, which is actually a mistake, and I'm going to show you now what everyone would do, okay, is that they say, okay, so now for standard deviation, we have here 9 degrees Celsius, so that means that C equals 9, and we need to find Fahrenheit, right? And so my equation that I'm using is F equals 1.8 C plus 32. And so that means that from here I can just plug in 9, ¿cierto? So I can just end up with F equals 1.8 times 9 plus 32. So that means that my Fahrenheit has to be just this thing here, just that right there we have a 9. And a lot of people would just say, yeah, okay, Fahrenheit is 48.2, bada bing, bada boom, I'm done. See? Now, this is incorrect. And it's very, very particular why it's incorrect. See? So on the one hand, it's partly incorrect. Okay. It is incorrect, sorry. Because of how the standard deviation works. See? So what is standard deviation? What is actually happening here? See? So let's go over these terms for a bit. And actually in the answer key here it says, recognize that the plus 32 does not affect standard deviation. Now, why would it not affect standard deviation is what I will explain now. So this is incorrect because you should be doing this calculation without 32. ¿Dale? Now, why is that the case? Let me explain it this way. ¿Dale? Technically, okay, your mean is the same as like your average. Okay, so that is a little bit more intuitive to understand. ¿Vale? While your standard deviation, I suggest that you recognize it more as like your spread. Okay, the spread of your data. If you have a very high standard deviation, that means your data is very spread out. If you have a very small standard deviation, your data is very like compact together, etc. Okay, so having that in mind, okay, imagine I have this scatter plot right here, see, which has, I don't know, these points of data. All right. If I were to, for example, do a +3 to all of these, ¿cierto? That means that my new points end up something like this, ¿cierto? They're all a little bit higher up, right? Makes sense. So, how would the mean change? The mean would change because all the values in red are much higher than the values in black. ¿Cierto? So the values in red for the mean would go up if you do +3. The average is bigger, it makes sense. ¿Cierto? But what about standard deviation? If you do +3, +3 to each, ¿cierto? You do +3 to each, does the spread of your data increase or decrease? It's actually the same. The spread of the points in black between each other is the same as the spread of the points in red, ¿cierto? They're not anywhere closer or farther than each other than what they were before. So the main idea here is that when you're looking at standard deviation, you only care about it changing if you multiply, ¿cierto? If you do +3, if you add or subtract by something, your spread is not going to change. But if you multiply by something, then your spread will change, ¿cierto? Because if from here you do, I don't know, like whatever, like times 100, ¿cierto? Imagine you're doing times 100. There your mean would definitely change, ¿cierto? But it's also interesting. Imagine you have a point of data that's over there, ¿cierto? So if you do times 100, all these values will go like way higher, ¿cierto? But some of your values, and here's the main point, some of your values will go way farther up than others if you multiply by 100. Because if your data is, I don't know, 1, 2, 3, 4, 5, if you do +3 to all of them, you end up with 4, 5, 6, 7, 8, ¿cierto? So here it makes sense that your mean is going to get bigger, but your spread is still the same. There's still a difference of 1 between all of these. But, so this is the case of +3, ¿cierto? But if you do times 2, what does it end up like? You end up with 2, 4, 6, 8, and 10. And in this case, yes, the mean went up, but so did the spread. If before they were spread out between each other by 1, which is the same as when we added +3, it was still spread out by 1, here it's spread out by 2. So, when you multiply, your standard deviation is going to change, but adding or subtracting does not change your standard deviation. So over here, for part B double I, basically, yes, you have to use this equation there, but you don't care about the +32 because adding or subtracting does not change your spread. If you add or subtract, your spread will remain the same. The spread only changes if you multiply. So in this case, the +32 is something you actually have to ignore. So you go ahead and plug into this equation, which is F equals 1.8 times C without the +32. Without the +32. So F has to equal 1.8 times 9. So F equals, F equals, thank you, 1.8 times 9 without the 32, Fahrenheit equals 16.2. See? So a little bit of a longer explanation of how standard deviation works. It was a very particular question. I don't tend to see that in the IB tests, but hey, here it was, and I think it was worth 2 points. So worth knowing how to solve it. See? So yeah, there it is. 16.2, 16.2. Ladies and gentlemen, that is for number 8. Not that complicated except for the last part. See? So I hope you learned something, and I hope it helped. All right, ladies and gentlemen, for number 9, we have the Kyung-yoon. I don't know if I'm saying that correctly, but Kyung-yoon investigates the rate at which a cubical block of sugar dissolves in hot coffee. Initially, the cube has side lengths. Okay, that's important. We're talking about side lengths of 10 millimeters. This information is illustrated in the following diagrams. So yes, it's a cube because it's just a bunch of squares lined up, ¿cierto? And all these different sides are all 10 millimeters. So Kyung-yoon predicts that as the block of sugar dissolves, each side length will decrease at a constant rate of 0.2 mm, and this is important, per second. And so for part AI, we need to find, according to the model, the length of one side of a block of sugar 20 seconds after it is placed in hot coffee. So it's specifically after 20 seconds how long I should say the length of one of these sides ends up being, right? And so we know that it starts at 10 millimeters, right? So it starts at 10 and it loses, so we're going to put a minus, right? It loses a certain amount of those millimeters per second. How many millimeters per second does it lose? It loses 0.2 millimeters per second. So in that sense, we can put 0.2 mm. I mean, sorry, not mm. This is all in mm units, right? But technically, it has 10 mm, right? And it loses 0.2 mm per second. And so in order to express this per second right here, we're going to go ahead and put 0.2x, right? So my function f of x, all it's really doing is that x is going to be seconds. My x is going to be seconds, and my y, which is the same as f of x, see, is going to be my length, all right? And it checks out because if I am at, for example, at 0 seconds, and I plug in 0 for x, so x ends up being as 0, it makes sense because this 0.2 times 0 is just 0. F of 0 is 10. So it makes sense that at second 0, before I even put it inside of the coffee, it's still at 10 millimeters, right? So all I have to do now for part AI is simply plug in F of 20 because we are talking about after 20 seconds, okay? So F of 20 has to be 10 minus 0.2 times 20. And so F of 20 has to be, let's go ahead and confirm with our calculator over here. 10 minus 0.2 times 20 ends up giving me 6. Okay, so the length of one side of a block of sugar 20 seconds after it is placed in hot coffee will in fact be 6 millimeters. Okay, so that is for part AI. For part AI, we need to find the volume. So this is a little bit different. The volume of a block of sugar 20 seconds after it is placed in hot coffee. So what the heck is the volume of a block of sugar? Well, the first thing we need to immediately say out loud is that a block of sugar is the same as a cube. Okay, it's the same idea. A block of sugar, cube of sugar. Okay, and the word cube or block is that in my formula booklet. I actually have no idea. But that's the point, ¿cierto? The day of the test, you're going to be walking in with a couple of things. A pen or pencil, an eraser, a calculator, 2 years of experience of this thing called IB, 2 hours of sleep, and the formula booklet. Guys, the formula booklet, you do not have to know it by memory, but you should know sort of what's inside of it. See? So the moment you read cube or block and volume, you should be thinking, there's a whole section in my formula booklet that has volumes, right? Let's see if it's in here. See? And lo and behold, I immediately see volume of a cuboid. Okay, so volume of a cuboid, volume of a cube, is simply going to be length times width times height, where L is the length, W is the width, and H is the height. And so over here for part A double I, well, what would be the length? Or actually, let me write the equation. See, so for part A double I, the volume is going to be length times width times height, and we're talking about after 20 seconds. See, so after 20 seconds, the length of one side of a block of sugar after 20 seconds, how much did it end up being? It ended up being 6 millimeters, right? And so this cube that used to be 10 per side is now a cube that looks something like this. See, so now instead of being 10 10 10 10 10, now it's going to be 6 6 and 6. Okay, so that means that length times width times height in this case is going to be 6 times 6 times 6, and that ends up being, let's find out, 216. Okay, so for part A double I, what we end up finding is that you do 6 cubed, 6 times 6 times 6, it gives you 216. The units are millimeters, so mm cubed. I'm going to go ahead and put it in blue so that we remember that that's the answer. And there it is. ¿Vale? So that would be for part A double I. Then they tell us that we need to let the function v of t represent the volume of the block of sugar, millimeters cubed, t seconds after it is placed in hot coffee. And that vt is given by this equation there. Okay, now let's go piece by piece. On the one hand, this is my equation, right? And on the other hand, the thing that I'm putting now in yellow, the t being between 0 and 50, all this is really telling you, or what it's defining you, is your domain. Okay, this is a classic. Sometimes they give the domain, sometimes they give the range. And all the domain really tells you is your possible values for x. Okay, and in this context, like your x, ¿cierto? Your independent variable in this context clearly has to be time because it's in here, ¿cierto? F of x, here you have v of t, so x is time while your y is going to be volume. Okay, so all we know is that this model right here for volume of a block of sugar in respects to t seconds after entering a hot coffee, blah, 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 blah. All we know is that this model is useful, or we're going to consider it, for between 0 and 50 seconds. Okay, we can't use above 50. All right, and so for part B, you need to find whatever this is. This, ladies and gentlemen, the weird stuff that they can throw at you are 3 things. Okay, or well, not weird things, but the functions that they can throw at you. You can have f of x, which is like it's the normal one. Okay, this is the normal one. Okay? Then you can have this, which will be the derivative. Okay, the derivative, and then you can have this, and that with the -1, ¿cierto? This isn't a 1, this is like an asterisk thing, much like that symbol here, and f to the power of -1 is actually going to be the inverse. Okay, these are the 3 sort of functions that at AISL they can throw at you. In this context, I need you to identify this symbol as a derivative, ¿cierto? So, derivatives, probably not too exciting. You probably didn't understand it in class, and that is why you're watching this video. So, what I need you to do when you face a derivative problem at the AISL level is that the moment you see it, you're going to take out your formula booklet, you're going to listen to this guy online talking about math, and you're going to scroll all the way down until you reach the calculus section, topic 5. And over here, the only derivative that we need to know for AISL is this derivative here, the derivative of the exponent. I do have a video explaining this a little bit more. I think it's called like derivative of an exponent 101 or something like that, but I'm still going to give you the rundown on how it works. See? What I really need you to focus on is what happens to your exponent, what happens to n, ¿cierto? So this right here, the x to the power of n, is before the derivative, and this with the derivative symbol is, well, after the derivative. So what happens to n? two things, okay? Two things. On the one hand, you're going to do minus 1 to the exponent, okay? And the other thing you're going to do is that you're going to sort of like multiply the exponent below, okay? Because notice right here the n dropped from above multiplying, so that's number 2, and we also did a minus 1 to the exponent, so that's number 1. See? Okay, one thing is looking at it here on the formula, okay? And you can sort of figure out what it does by really focusing on what is happening to n. But really, for me at least, learning the derivative of an exponent, it helped me a lot more to see examples. So let me give you like 2 or 3. See? You can have the example of x squared, which if you do the derivative, you end up with 2x, because this 2 is going to multiply in front, and then 2 minus 1, because you got to do minus 1 to the exponent, ¿cierto? So that ends up as 2x to the power of 1, which is the same as just leaving it as 2x. Let's do another example. Let's say you have x to the power of 3. That means you end up with 3x to the power of 3 minus 1 equals 3x squared. And the last example I'm going to give you is actually 2 more. See? Imagine we have 2 times x to the power of 4. So that means I end up with 2 times 4 times x to the power of 4 minus 1. So that means I end up with 8x to the power of 3. And the last example I'm going to give you, which is kind of wild, it doesn't usually happen, but if you do run into it, it can be something like, I don't know, 1/2 x to the power of 3. See? So in this case, you end up with 1/2 times 3 times x to the power of 3 minus 1. So that means you end up with 3/2 x squared. See? So that one's a little bit crazier because you're working with a fraction. Oh, and the last thing I'm going to show you now that I'm, talking about this, whatever, I'll just jump into it. Who cares? You can skip ahead if you already know it. But you can encounter something like 1 divided by x. See? So if you need to do the derivative of this, 1 divided by x, all you need to do is like before the derivative, ¿cierto? So before the derivative, so this is before derivative, okay? It's very important that we understand that this is before the derivative. Before the derivative, what you can do is put this x on top, right? And in order to put it on top, all you need to do is put x to the power of -1. Let's remember that anything that has a negative exponent, you kind of like flip it, see? So x to the power of -2 ends up as 1 divided by x squared. 3x to the power of -3 ends up as 3 divided by x to the power of 3, okay? And so before the derivative, you're going to flip it, and then you do the derivative. And so if from here you do the derivative, you end up with -x to the power of -1 minus 1, which effectively gives you -x to the power of -2. And if you want to write it more nicely, you end up with -1 divided by x squared, okay? So I pretty much showed you everything you need to know for the derivative of an exponent. So from here, it should be fairly easy to do. All right, coming back to reality, for part B, you need to find the derivative of this whole thing, and we gotta go piece by piece, see? So if I do the derivative, actually, yeah, let me write it here. See, so v of t is 1000 minus 60t plus 1.2t squared minus 0.008 t to the power of 3, right? So if you go ahead and do the derivative from here, okay, if you do the derivative from here, it's very interesting to what happens with this first term, right? Because as we saw in the formula booklet, the derivative of an exponent, like the exponent goes down multiplying, ¿cierto? And it has an x next to it, right? It has an x next to it. So what do you do when there isn't an x next to it? Well, technically, it does have an x next to it, see? And this is going to be kind of crazy, but technically right here, notice how all of these are being multiplied by t, ¿cierto? T to the power of 1, t squared, t to the power of 3. Technically, this 1000 is also being multiplied by a t, just that this t is to the power of 0, because anything to the power of 0 is going to equal 1, and 1000 times 1 doesn't change your outcome, see? So, point is, technically there's a t to the power of 0 there, ¿cierto? And so if there's a t to the power of 0 right there, then that means that for this first term, we end up with 1,000 times 0, ¿cierto? Because the exponent multiplied right in front, times t to the power of 0 minus 1. For this next term, we end up with minus 60 times 1 times t to the power of 1 minus 1, because this is to the power of 1, ¿cierto? For this next term, we end up with plus 1.2 times 2 times t to the power of 2 minus 1. And for this last term, we end up with 0.008 times 3, because this 3 is now multiplying in front, times t to the power of 3 minus 1. See? Now all these minus 1 solve pretty easily. This first term is being multiplied by a 0, so all of it ends up being 0. And what you end up with at the end of the day, well, this first term is 0, the next term ends up being just negative 60 times 1. This 1 minus 1 gives you t to the power of 0, which is just 1. So this is multiplying by 1. See, we don't really care about that. All I really end up with is minus 60. ¿Vale? So this next term is going to be minus 60. This term here, so this ends up minus 60. This ends up being 1.2 times 2, so 2.4 times t, so plus 2.4 times t. And for this last term, you end up with 0.008 times 3, so that should be minus 0.024 times t to the power of 2. Okay, and just so that you believe me, we are talking about number 9. And well, there's the 6, there's the 216 that I mentioned earlier, all good. And for part B, there it is, the negative 60 plus the 2.4 minus the 0.024. So that would be for part B. Okay, and now for part C, we need to find the rate of change of the volume of the block of sugar at t equals 20. This is extremely easy, but you need to understand how derivatives work. See, so you need to find the rate of change. Find the rate of change when t equals 20. Now I need you to understand this very key concept, ¿cierto? When we're dealing with like the original, when it's f of x, right? Think about it this way. If you plug in an x, you're going to get a y, okay? And let's say you plug in x of 1, you get a y of 2. That means you end up with that set of points 1, 2. Makes sense, right? If you have the derivative, okay, and you have an x and a y, and you plug in, I don't know, x of 3 and end up with a y of 7, then yes, this is also technically 3, 7, but the interpretation for the derivative is a little bit different, okay? For the original one, you have like, you get like a set of points, ¿cierto? 1, 2, if x is 1, y is 2, blah, blah, blah. There's not, I mean, depending on the context, it can give you something, but the derivative, the interesting thing about it is that now your y has turned into rate of change. So in this imaginary example that I gave up, when x equals 3, slope equals 7. Slope is the same as rate of change, okay? So the slope equals 7 when x equals 3. And that is the information that the derivative gives you. And you can also work backwards, by the way. If you go ahead and plug in, I don't know, a y of 0, and you discover an x of 2, then that means, and this is very useful for parabolas, okay? That means that right when x equals 2, you have a slope of 0. And wherever you have a slope of 0, always has to be a maximum or a minimum. See? So I'm just telling you, this is what derivatives are for. That's usually what it's used for. A lot of times you equal your derivative to 0 because you're asking the function when the slope is 0, what is x? And that can be extremely useful for finding maximums or minimums, optimum points, stuff like that. So back to reality once again. These monologues where I teach random stuff, well, I'm sure it's useful, but videos end up being a little bit longer. So for part C, you need to find the rate of change of the volume of the block of sugar at t equals 20. So technically what you're doing is you're going to plug in 20 for x and find whatever your y is. How come you plug it in for the derivative and not for the original one? Because the original one in this context, you give t, you get volume, ¿cierto? You give t as time, you get y as volume. And now with the derivative version, yes, x is still time, but now y is slope or rate of change, ¿cierto? Same thing. So now your x is still as time, but your y is now a slope. And so they're telling you that the t is 20, your x is 20, and what is the slope, right? That is what you're dealing with. What is the slope when x is 20? And so of course I gotta use the derivative version that I have right here. So if you go ahead and plug in 20 into that, you end up with negative 60 plus 2.4 times 20 minus 0.024 times 20 squared. So if I put all of that into my calculator, we end up with negative 60 plus 2.4 times 20 minus 0.024 times 20, and that guy squared. See? Go ahead and press enter. You end up with you end up with negative 21.6. Yeah, negative 21.6. And if we go ahead and check the answer key, there it is, right? Now, because this context is within volume, ¿cierto? You end up with a very weird sort of unit. Because we're talking about rate or slope or whatever, then we're talking about, oh, you're losing at 20 seconds, ¿cierto? At 20 seconds, you're losing 21.6 like cubic units of millimeter per second, ¿cierto? And that's why over here they express it like that, ¿cierto? Remember how I mentioned earlier that anything to the power of 1, you just flip it? Well, saying mm cubed times s to the power of negative 1 is the same as saying mm cubed slash s, which is what we're used to seeing, because mm cubed slash s is the same as mm cubed divided by s. See? These are all the same. Now maybe you understand the negative 1 a little bit more. See? Yeah. Enough blah blah. That was for part C. And the last blah blah that you have to go through is part D, which says, fairly easy, state one reason why the side length of the cube may not always decrease at a constant rate. And this is interesting for two reasons. First of all, because it's a classic question, it's like a reasoning context sort of problem. But secondly, because it allows me to tell you, dude, if the day of the test you're scratching for points, ¿cierto? You're trying to get as many points as possible, and there's a couple questions that you left unanswered because you weren't sure about them or you were running out of time or something like that. Try to be on the lookout for these sort of like context questions, okay? Because these context questions, although they tend to be only worth 1 point, you need to realize that you do not need part A, you do not need part B, and you do not need part C in order to answer these context questions. So if you're running low on time and you want to get a couple extra points, be on the lookout for context questions so you can answer them quickly, or maybe even answer them right away. You know, why not? Who cares, ¿cierto? But yeah, so in this context, we need to state one reason why the side length of the cube may not always decrease at a constant rate. And let's first understand that when they say a constant rate, it's like a number that like, how do I say it? It's always the same, ¿cierto? Imagine I tell you my height, ¿cierto? So since I was 1 year old until I was, 18 years old, my height always increased every year by 10 centimeters. And that's not true, right? When I was a baby, I was very small for quite a while. And then when I was a teenager, I grew a lot in very little time. It wasn't always 10 centimeters per year, right? And the same sort of reflection can happen within this context, right? Why would the length of a cube may not always be a constant rate? One of the reasons that comes to my mind is, for example, I imagine that the smaller it is, the faster it sort of fades away, or the faster it decreases its volume, because the whole shape is like a little bit weaker, right? You can also say like the cube the first second is not so hot, and after 20 seconds it's very hot, so it's gonna decrease faster. There's a lot of things you can say here, guys, okay? Just go with one of them and make sure you answer as completely as possible. I think for these questions, it's better if I show you the answer key so you understand the sort of stuff you can say. But over here, the answers that they accept, not only is any reasonable explanation, but also they give some examples. So decreasing or changing coffee temperature, the temperature of the coffee is also changing, right? Decreasing or changing surface area of the cube, that's what I meant about the cube getting smaller, right? The cube breaks apart into smaller pieces. I did not consider that, but it's a little bit related to the second one, right? And the dissolution rate related to the volume of the cube, that's very much related to the second thing I said. See? So again, for these exercises, for the context problems, for the context part of the problem, there's a lot of different stuff you can say. Just trust your gut, think about it logically. You only have to give one. Okay, you only have to give one. It's 1 point. Don't stress over it. This should be a quick and easy sort of question. Trust your gut. That it? Ladies and gentlemen, that would be for number 9, and I hope I helped. If there's something I can say about these sort of exercises, is that finding the derivative at the AISL level is very easy. Take your time to learn it, because for me at least, it's very easy, 4 points. And I'm just saying, there's usually at least 1 or 2 questions with derivative within the IB exam for AISL. So worth looking into it. It's worth studying. You should get those points pretty quick, ¿cierto? And if we consider like the amount of time you spend on a question and how much points it gives you, for me, derivatives tends to be the better one in that sense. Like usually they say like, oh, you spend a minute per point. I don't think you end up spending 4 minutes with the derivative and the rate of change and all that stuff. See, derivatives are pretty quick. This video is longer because I'm explaining a lot of stuff, but you should reach the level where doing the derivatives that I drew, for example, over here, should be very, very easy for you and very, very quick, okay? Eventually, maybe you even skip the step of like writing out the in-between step, and you effectively go from here to here more easily, see? Point is, derivatives are worth looking into. They show up a lot in the tests, and that's just an additional tip I wanted to give you for the day of the exam. So now, for sure, I hope I helped. I'll see you around, and take it easy. Alright, you guys, so number 10, I'm going to say right away, is a very specific problem that is solved in a very specific way, and I don't usually see it in the IB exam. Okay, so if anyone is watching this and they're like, oh my god, I don't understand anything, this is so confusing, I just want you to let you know that this is very rarely asked. And when I say that it's very rarely asked, I mean like this type of problem. See, they do ask a lot of times like express x in terms of y, express m in terms of h, and that's like a classic, ¿cierto? But here they go one step further, and you're about to see how and why. And that is the specific type of problem that doesn't get asked too much. So if you have the test tomorrow, it might be better to study something else. See, this is a very, very specific thing that does not get asked much. But we are in 2024, and who knows how 2025, 2026 are going to be. So just so you know, not a common question that they asked at the AISL level, but one that is worth knowing to get these easy sort of points. That it? So, that being said, we have that when studying big cats, researchers use a model in which the mass m kilograms of an animal is directly proportional to the cube of its shoulder height h meters. There we have 2 cute drawings of 2 cute little kitties, and we have that a cheetah has a mass of 64 kilograms and a shoulder height of 0.8 meters. And through all of this, for part AI, we need to use the model to find an expression for m in terms of h. So the first thing we have to go over is that when they say m in terms of h, all they're really telling you is that you need to reach m being alone. Okay, m has to be alone, and then somewhere on the other side you have h. See? I say somewhere on the other side because you can have like 3h or 3h plus 4, like whatever, ¿cierto? But the important thing is that when they say m in terms of h, m, this first one that they mention, has to be alone. That is also why when they say y in terms of x, you have to reach y equals blah, 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 x. See? So keep that in mind. Okay, so m has to be alone, and h can have something next to it. See? So m equals something something h. Use the model to find an expression for m in terms of h. What do you know about how m and h are related to? Well, they told us earlier that the mass of an animal is directly proportional to the cube of its height. All right, when they say to the cube, I mean, there's two main things that can show up. ¿Cierto? They can talk about something that's squared or something that's cubed, which is this case. All right, if something is squared, that means it's literally squared. ¿Cierto? Like x squared. Well, x cubed is x to the power of 3. Okay, squared, cubed, squared, cubed. Why is it squared? Why is it cubed? It's squared because technically when it's to the power of 2, we're in 2 dimensions, right? So we're dealing with a 2-dimensional plane. You have a square. While it's cubed, it's technically 3 dimensions, 3D, right? And you end up with something that looks 3D, which could be something like a cube. See? So that's why squared is to the power of 2, and that's why cubed is to the power of 3. Now that we have established that, we can go ahead and say, yep, so clearly we can have that m mass is basically just going to be the height cubed, ¿cierto? So this is where everyone goes ahead and says, okay, so m equals h cubed, and they're done, ¿cierto? Okay. This is what I mean that it's a very specific problem that is solved in a very specific way, and that it has like something awfully like, I don't know, you either know it or you don't, ¿cierto? If this was the answer, then plugging this in should make sense. But if you try to plug that in, you end up with 64 equals 0.8 cubed, right? And so from here, if you go ahead and do, and making sure your calculator has batteries, here you can do 0.8 cubed, and you end up with 0.512. Does 64 equal 0.512? No, it does not. So clearly this answer that I put up top is wrong, ¿cierto? But how is it wrong? They just told me that the mass of an animal is directly proportional to the cube of its shoulder height, which is what I'm putting here. Why doesn't the math make sense? Okay, it doesn't make sense, and this is the weird part, and I have no other way to explain it. But the weird part is just like, okay, if it doesn't make sense, ¿cierto? Then clearly on the other side, something needs to be multiplying h, ¿cierto? Something needs to be multiplying h, and that's what we're going to put. Something, which we're going to call a, is multiplying by h cubed, okay? How do I know that a is on this side with the h and not with the m? Because we are trying to find m in terms of h. So m has to be alone, so that a has to go with h. And yes, this sounds crazy, but it is also here on the answer key. ¿Vale? So m equals a h cubed. Now we can plug in the information of 64 kilograms. So that means we end up with 64 equals a times h, which is 0.8. 0.8 will be to the power of 3. As we found earlier, this ends up as 0.512 times a. So a has to be equal to this 64 being divided by 512. And doing some quick maths, I think that might be 125. That's 125. So a equals 125. See? So now that you found that a equals 125, to complete your model, you can leave it as m equals 125 h cubed. See? So that is the awfully specific thing that you need to know for part AI. After that, the rest of the exercise, it's still pretty tough, but this first step is huge, okay? Unless you have somewhere in your brain that you need to multiply that h times an a, you're not going to solve any of this, ¿cierto? And why does it multiply the h and not the m? Because you're trying to find m in terms of h. M has to be alone, so a can only come into the h. And how did you know that you have to put the a? Because you checked earlier and you ended up with 64 equals 0.512, which does not make sense, which means that your initial model of this is not good enough. You had to put the a in between it. Got it? So that's the weird thing. I haven't seen it asked much in the IB. Yes, it's worth knowing if it shows up. It doesn't show up often, at least up until 2024 before the November exams. See, that is my current perception. Not a common question, but I mean, I guess once in a while they put it in there. See, so good to know. That's how you solve it. That is for part AI. Later on for part AI, we need to find the mass of a different cheetah with a shoulder height of 0.75 meters. So fairly simple. Now for part AI, what we have is that m equals 125 h cubed. And so basically for part AI, what's happening is that you need to find the mass. So m equals something, and the height is 0.75. So h equals 0.75. So you know that the height is 0.75, and you don't know the mass. So you're going to be plugging in over here, and you're going to be able to find that, which makes sense because you end up with only one variable. So basically what you end up with is m equals 125 times that h, which we said was 0.75, to the power of 3. So m equals whatever that is. Let's figure it out. 125 times 0.75 to the power of 3. So m equals 52.734. And if you want to count in significant figures, you go 1, 2, 3. Do you round it up or keep it the same? You keep it the same. You can leave it as m equals 52.7 kilograms. Cierto, our units are kilograms. If you go over here, sounds pretty good to me. See? So that would be for part AI. Dale? Now it gets very exciting. Okay? So go ahead and start reading. Here we have that Rubner's law states that the energy needs of an animal are directly proportional to the square of h. So here we have that energy has to be h squared. And that the energy needs of a lion of a mass 220 kg are k times the energy needs of a cheetah of mass 64. So that is a loaded question, but it is worth 4 points. It is worth the effort. And so from here, we need to find the value of k. Now this one is a fairly easy sort of exercise, but your approach needs to be very, very sort of like organized. See, if you're not organized in your approach, you're not going to know what's going on. You're not going to get it right. So what do you know, cierto? You know that energy equals h squared. You also found from earlier, from part A, that m equals 125 h cubed. So you know that energy equals h squared. You know that m equals 125 h cubed. And notice, in part B, they're not giving you heights, they're giving you a bunch of mass. They're giving you mass. So technically, you don't really care about height, even though your energy function isn't height. So, ideally, you want to have energy equals something, something m. So how can you reach energy equals something, something m? Well, this h right here, if I replace it with that h, I'm going to end up in terms of m. Okay, so how the heck do you do that? Well, let's go ahead and take this function here, which we're going to call our second one. This is our first, cierto? So if we go ahead and take our second function and leave it in with an m, cierto? Or h in terms of m, better said, cierto? If we leave our second function with h in terms of m, and plug it into the first one, we're going to end up with our third function, which is going to be energy equals something, something m, which is going to help us a lot because for part B, all information they give us is simply mass, no height, cierto? So taking this second function and trying to get h alone, so h in terms of m, how can we start off with this, cierto? You can divide by 125 to both sides, so h cubed equals m divided by 125, and from here, in order to get rid of this cubed, what you actually have to do is the square roots with a little 3 here, cierto? So the square root with a little 3 here will effectively make this go away with this. And what you end up with is that h equals this whole thing, ¿cierto? All right, perfect. So now that you found h in terms of m, you can plug that in over here, right? And that means that my third equation that I mentioned earlier is going to end up being as energy equals parentheses 3 square root m divided by 125, and all of this squared, ¿cierto? So all of this squared, and now I just passed from having an energy function in terms of h to an energy function in terms of m, which is perfect because all of this up here is in terms of m. So what were they asking exactly? They were asking for the energy needs of a lion of mass 220 being k times more the energy needs of a cheetah. Okay, so what is the energy needs of a lion? So the energy for lion, so EL, ¿cierto? E sub L, energy for lion has to be 3 square root 220 divided by 125 and all of this squared. So if you go ahead and plug that in, ¿cierto? We're going to find the energy needs of lion. Yeah? Now, how do you put that little 3 outside of the square root? You have to go to the math button under alpha. So go to the math button, and then over here, you should have that same symbol. So you press here, and now you're going to be putting a fraction. So you actually go alpha y equals the first one in order to put a fraction. This is not something you have to do, but it does make your life easier. And all of this needs to be squared. See? So something that I missed earlier, just so that I feel more comfortable with inputting into the calculator, is first putting a parentheses. See? It's just a thing that I like to do. Work with parentheses, makes it smoother, yeah, whatever. See? So that way with the parentheses, I make sure that I am squaring the whole thing, ¿cierto? So now I close the whole thing, I square the whole thing, I press enter. The energy of a lion is this number here, the 1.4577. 1.4577. So that's energy of a lion, see? Very important. We will be using it in a second. Okay, what's the energy of the cheetah? Energy cheetah. So energy cheetah is with a mass of 64. See? So that means I would be plugging in the same, almost the same thing, just that my m, instead of being 220 from earlier, now it's going to be 64. 64 divided by 125 squared. See? So energy of cheetah is the same thing as before, just that instead of putting a 220, instead of putting a 220, we will now be putting 64. So go ahead and press enter. We end up with 16 divided by 25. I want to leave it in decimals just so that it's more comparable, right? So decimal is 0.64. See? So this would be the energy of the cheetah. Dale? And the last step we have to do for finding the value of k is that now that we have the energy needs of a lion and the energy needs of the cheetah, read carefully. The energy needs of a lion of mass 220 are k times the energy needs of a cheetah. This right here is the most important part. Are k times the energy needs of a cheetah. See? So, the energy needs of a lion energy needs of a lion, see? Of mass to 20 kg, blah, 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 of mass to 20 kg, ¿cierto? R k times the energy needs of a cheetah. This word right here, the R, is extremely important. That, in terms of math, is technically your equals sign, see? So that is your equals sign. This k is simply k. The times means that you're going to be multiplying, and the energy needs of a cheetah, you just found them. Energy needs cheetah, right? And over here you had energy needs lion, ¿cierto? So energy lion will be equaling k times the energy needs of a cheetah. So that is how you turn these words into math symbols. See, it's very important that we identify that the R is going to be my equal sign in this context. See, so once we establish that, we can literally write down the equation. Energy of lion will equal K times energy needs of cheetah. So we plug in what we found, we end up with energy needs lion, which is the 1.4577, equaling K times the energy needs of a cheetah, which was 0.64. So for finding the value of K, you just need to get K alone. Divide both sides by 0.64. That means this goes away with this. You end up with K equaling whatever that division is, which, by using the calculator, ends up being 2.277. 2.277. If you want to do significant figures, you count 1, 2, 3, round it up or keep it the same. You round it up. Significant figures would be 2.28. We check the answer key just so that you believe this guy online. Not that you should believe guys online, but in terms of math, you can't believe me. There is the 2.28 and there's the 2.27769 that I mentioned earlier. See? So, guys, this exercise, my personal opinion, it's not that hard, but it is extremely specific. If you don't catch on to the thing of needing to put m equals ah cubed, you're never going to solve it. Literally, you're never going to solve it if you don't understand that you need to put the a in front of it. See, it's hard to explain why. And my approach, at least, or what I tend to do with these exercises, is that initially I thought it was m equals h cubed. I plug in these values, it didn't make sense. And so if it didn't make sense, that means that my h has to be multiplied by something. And I multiply h by something and not m because you are trying to find m in terms of h. I know I've said that like 10 times, but it's extremely important we understand that m in terms of h means that m is the one that's alone and h can have something multiplying. So if you try to plug in the numbers and it doesn't make sense, there's probably an a going around. So plug in a, find a. This is your actual model. See? Ladies and gentlemen, that is for number 10, a very specific problem, not something that gets asked too much in my experience, but, well, maybe it's going to gain popularity between the IB examiners, the guys that create tests, whatever, I don't know. See? So keep it in mind, once you know the A thing, everything else is just being organized. That it? So, I hope it helped, and that is for number 10. Alright, you guys, check it. So for number 11, we have that the following diagram shows a semicircle. Okay, that's interesting. It's a semicircle with center O and diameter PQ. A rectangle OABC is also shown, such that AB is 8 and OA is 5. So, let's first make sure that everything is written down. AB is indeed written down for 8 and OA is indeed written down for 5. It's important to notice that this is in fact a semicircle. So all we really need is to find the length of the arc BQ. So you guys, right off the bat, whenever you're facing circles at the AISL level, the sort of thing they can ask you to find is either length of arc, which is in your formula booklet, length of an arc, or area of a sector. These are the only two main things you really have to sort of like worry about, and there's not much to it. You might have to get creative with how to find some of the variables, but as long as you understand that these are the things that they can throw at you, then you should feel a little bit better. So in this case, we're going for length of an arc, so let's go ahead and write down the equation over here. So following the formula booklet, length, L for length of an arc, is going to be theta, which is going to be the angle, okay, facing my arc, divided by 360 times 2 pi r. So notice, technically from here you have three variables. You have L for length, you have theta for angle, and you have r for radius. Okay, now because you need to find the length of arc BQ, that means that I can leave length by itself, and I need to find the angle, and I need to find r. So once we take this approach of, okay, identifying the type of exercise, which is a circle problem, seeing that we have the formula for length of an arc and writing it down, and then really having very clear which variables we need and which ones we don't. And in this case, we need the variables in red, which is the theta and the r, which will end up giving me the length of our arc L, ¿cierto? I mean, length of the arc BQ with L. Once we establish that, now it's easier to have clear what we need to get first, ¿cierto? And so, if we're talking about the length of the arc BQ, let's go ahead and sort of like draw that, and I will be drawing that in blue, see? So if I go ahead and draw that in blue, the length of the arc, ¿vale? Let's leave very clear that when we're talking about an arc, okay, so in this case, arc, ¿vale? An arc is going to be like, or actually, let's do both, see? So if you have a circle like this, and let's say that this is your center O, see? And then here you go with R, here you go with R. If we're talking about length of an arc, this, for example, could be length of arc. And when we're talking about area of a sector, we're talking about this area here. So that is length of an arc. And this area is area of sector, okay? So just for us to have very, very clear the kind of thing that can come at us, in this case, we're going for length of an arc. And so in this case, because we're talking about length of arc BQ, that means we're talking about this arc right here. From B all the way over to Q. So this, ladies and gentlemen, is the length of the arc that we're trying to find. Now, the other thing that can really, really help us with this exercise is understanding that when you're trying to find the length of an arc, you need R, ¿cierto? And much like the example that I drew here, for length of an arc, I first drew the origin. I first drew the origin right there, ¿cierto? O for origin, okay. This is the origin, lul. And so you first start from your origin, you see the length of your radius, and these two lines, as you can see, these two lines are exactly what help you define which arc you're going for, ¿cierto? So these two lines help you identify that I'm going for this arc here. And so here, working a little bit backwards, this arc in blue means that my two lines are from Q to O, because again, always to your origin, ¿cierto? Always to your origin, and from B to O. And so, the moment you do that, this exercise becomes a lot easier. Why does it become a lot easier? Because you just drew from point O, which is the center or the origin, over to the edge of the circle Q. So that means if I'm going from the center of my circle with O over to the edge of my circle in Q, and I know this is the edge, by the way, because it's part of the arc, ¿cierto? It's part of the semicircle because it's part of the arc that you're trying to find. If it goes from O to Q, that means that this right here is a radius. And from O to B is also a radius. They're the same value, ¿cierto? If this one's 3, that one's 3, they're both radius, ¿vale? And so, oh wow, look at that. How convenient. OB is part of rectangle OABC, so that means that right here, kapow, you end up with Pythagorean theorem. So let's recall that with Pythagorean theorem, which usually looks like this, you have 90 degrees here, you have A, you have B, and you have C on the long side. Remember that C is part of the hypotenuse, it's part of the long side, it's the side that is to the opposite of 90 degrees. The Pythagorean theorem tells you that with a 90 degree triangle, you have A squared plus B squared equals C squared. See? So in this context, your C squared would be R because R is to the other side of the 90 degree. It's part of the long side, it's the hypotenuse, it's the slanted side, all that stuff. And so in this context, you can immediately say that 8 squared plus 5 squared has to be R squared. And so 64 plus 25 has to be R squared. So R squared has to equal, I think that's, how much is that? It's 89, I think. See. So, 8, yes, 89. And so R is going to be the square root of 89, ¿cierto? And so immediately we can already say that, okay, this value here has to be R equals square root of 89. And so on the one hand, I already got this radius, ¿cierto? And the next variable I need to find in order to plug in is this angle, ¿cierto? Now this angle, given the context, is the angle measured in degrees, ¿cierto? And so following this diagram that I put earlier, I didn't draw it in, I'll draw it in now. This angle that is formed by the two lines is what we're gonna call theta. Okay, this angle formed by the two lines is what we call theta. So in this context, theta is going to be whatever is formed by these two lines, these two radius, or radii, or however you say it. And so this is actually the angle that you're going for, ¿cierto? So, oh, okay. So how do we go from there? What do we do now? And the main thing that should be coming to your mind at this moment, ¿cierto? Or once you establish or you recognize that we're talking about a rectangle, much how it says over here the answer key, just so that you believe me. Da da da. B-O-Q. Alright, so now we need to find this whole angle that's in red. See? Now notice, on the one hand, this whole angle that's in red, we can quickly establish, ¿cierto? Because it's next to a rectangle, that there's a 90 degrees right here. See? So I know that part of my angle in red is going to be 90 degrees. See? Now it's going to be 90 degrees plus, ¿cierto? Plus this angle there, ¿cierto? And this angle here is like the hard part of this problem. See? We're going to call this angle here x degrees, okay? So how the heck do you find x degrees? The thing is, the moment you find x degrees, you can do x degrees plus the 90, that gives you theta. And that means you can plug in for the theta, you already can plug in for r, bada bing, bada boom, you can solve. See? So how the heck do you get x degrees? Well, let's go ahead and draw our information. See? A lot of times it's good to sort of draw what you have to see what you're dealing with, this or that, etc. See? And so what you're dealing with right now is that part of the 90 degrees is point A, ¿cierto? And then when you go over this like height part or whatever, you have B, and over here you have O, okay? You know that from AB is 8, AO is 5, and BO is R, which we just found the square root of 89. And where is angle X? Angle X, as you can see, is between B, O, and A. So between B, O, and A, you have angle X, okay? So how do you find angle X from here? Of course, because you're trying to find angles and you're dealing with triangles, this is a trigonometry problem. That it? Trigonometry problem. Now, I know there's a lot of different methods and techniques for trigonometry. I know that you can use SOHCAHTOA, this or that, etc. And what I like to suggest, okay, what I like to suggest is that you use the same method always. And so the method that I always suggest for trigonometry problems is first, try with sine rule for the AISL level. See, try with sine rule. And then if it doesn't work, go to cosine rule, okay? Now I have other videos explaining sine rule and cosine rule a lot in depth, but the quick sort of 101 is that for sine rule, okay, if I go over here with sine rule and cosine rule, you notice that you have big letters and small letters. See, you have big letters and small letters all over the place, and notice how the big letters are always part of a sine or of a cosine, and that's because whatever you put inside a sine or cosine has to be an angle. So what am I telling you here? That big means we're talking about an angle, while small means we're talking about a side. And how do you associate these angles to the sides? ¿Cierto? If you have big C, how do you know what's little c? Well, take a look at this triangle here. If this is angle A, then little a has to be over here. If this is angle B, then little b has to be over there. And if this is angle C, then little c has to be over there. See, that's like the basic 101 of sine rule. And so in this context, you're trying to find angle X, ¿cierto? So my method for trigonometry is first trying sine rule. If that doesn't work, cosine rule will work. See, there is no third option. At least for AISL, this is a pretty good strategy. ¿Vale? So having in mind the sine rule, let's think about what is related to this angle X. So remember, you gotta like see what's on the other side. See, so angle A has related to it whatever side is sort of like facing it. See? So in this case, angle X has the 8 facing it. So that means that following this formula here, ¿cierto? I can go ahead and say that 8, which is side 8, ¿cierto? Divided by sine of X has to equal, and now I need to consider another pair, ¿cierto? So for example, this angle here, I do not know it, so why would I pair it with a 5 if I do not know it? It's a lot of extra work. Instead, you know this angle here. You know that this angle is 90, and it's related to the square root 89. So that means I can put square root 89 divided by sine of 90. And from here, because you need to get X alone, you can just go ahead, and what I like to do, the first step is always cross multiply. So that means you end up with 8 times sine 90 equals sine X times square root 89. Now you want to get X alone, ¿cierto? So you can divide both sides by square root 89, divide by square root 89. This goes away with this. You end up with sine X equals 8 times sine 90 divided by square root 89. Now, you want to get X alone, ¿cierto? And X is inside of sine. And so what do you do here? Well, just to explain it in very, very simple terms, if you have 2x equals 4, what do you do? 2 times x equals 4, you divide by 2. You divide by 2 because division is the inverse operation of multiplication. So you end up with x equals 2. Now the thing is, what is the inverse operation of sine? The inverse operation of sine is sine inverse. Look at that. So if you put sine inverse over to both ends, what happens is that this goes away with this, and you end up with x degrees being equal to sine inverse of this whole thing. 8 times sine 90 divided by square root 89. See? So you put all of that into your calculator and trust the process, and it'll work. See? So make sure that you can go to mode and have it in degrees. If it's in radian, you're going to get the wrong answer. So we're going to go ahead and do sine inverse. Put a parentheses with alpha y equals, then press the first one. 8 times sine 90 divided by square root of 89. Close everything. See what happens. You end up with 57.99. So x degrees has to be 57.99. If you think about it in terms of significant figures, you count 1, 2, 3, round it up or keep it the same. You round it up, so you can actually leave x degrees as 58. Okay, x degrees is 58. And we said that angle theta is going to be 90 degrees plus x degrees. And you just found that x degrees is 58. So that means that theta, ¿cierto?, is going to be 90 plus 58. 90 plus 58. Angle theta ends up being 148. So now, ladies and gentlemen, we can finally plug in with everything we have found. You found your radius, you found your theta being equal to 148, and now you can plug in to find the length of arc BQ. And if you go ahead and do that, for example, here you end up with my angle we said was 148, and my radius we said was square root of 89. So you put all of this into your calculator, trust the process, trust the formula, and you end up with, let's find out, times 2 times pi times square roots of 89. So you put all of that into your calculator and end up with 24.368. So 24.368. We are talking about a length, so we can leave it as, they actually don't give you the units. You can just say this amount, see, 24.368 units. If you think in terms of significant figures, you say 1, 2, 3, round it up or keep it the same, you round it up. So you can actually leave this as 24.4. All right, and if we go to the answer over here, there is the 24.4. See? So, ladies and gentlemen, Notice how here we find the radius. Here there's a couple different methods, but as you can see, they get into arctan and this and that. They use SOHCAHTOA. And personally, although it works, I always found it a little more confusing. And I like to show you or teach you methods that might take a little bit longer but always work. See, so in this case, the method that takes a little bit longer but always works for trigonometry problems is this approach. First try the sine rule, then go to cosine rule. Forget about everything else. This works for AISL. For other levels, not so much. That being said, that is number 11, and I hope it helped. Alright guys, here for number 12, we have that SAC raises funds for a library by running a game where players spin a needle. The final position of the needle results in an outcome where a player wins or loses money. The outcomes with associated probabilities are shown in the following diagram. So as we can see, here is the needle thing that is spinning around. And notice, some of these are wins, some of these are lose. So you win $5 with a 40% chance, right? And the rest of them actually are lose $8 with a 10% chance, lose $5 with a 20% chance, and lose $10 with a 30% chance. Okay, so that's that. See, so then they tell us that let X represent the amount that a player of this game wins, and for part AI, we need to find the expected value of X. Okay, this is a classic. In my experience, they tend to ask expected values like at least once, either in paper 1 or paper 2. They ask it at least once. Okay, it's a pretty common sort of thing that you do have to know. And if you pop out with your formula booklet and you go to expected value, it doesn't help you very much, because you look at this expected value formula, which is right here, and you look at it and you say, I don't understand this. Okay, and I'm gonna be honest, this isn't very intuitive. Okay, so let me try to break it down for you. Okay, think of this X, okay, as like, it's sort of like the outcome. Okay, so this X is going to be like the outcome, which for our context, it's going to be win or lose. And this whole thing, which I am now putting in whatever, in green, okay? Damn it, I don't think this is going to work. Nope. And the thing that I'm now putting in green, this whole thing, okay? Because it has the big P, okay? It's going to be the probability of that outcome. All right. And this last symbol at the end, or at the beginning, sorry, this should be a symbol that you sort of recognize. This is like a, I know how to say it in Spanish, una sumatoria. In English, I don't know if it's summation or what, but point is, it's like you're adding all of them. See? So this is basically telling you, you will be adding all of the multiplications between outcome and probability of that outcome. See, so for expected value, all you have to do is multiply the outcome of a single thing times the probability of that single thing and add all of them together. See, that's basically what's happening here. And so having that in mind, now that it's a little bit more clear, for the expected value in this case, right, as I said, it's the outcome times the probability of that outcome. So in this case, winning $5, right? So winning $5 times the probability of that outcome, which is 40%. How is 40% as a decimal? 0.40, okay? So, and all we have to do, because it's a summation, is add all of these together. So this is the, let's associate some numbers to it. See, so this is for the first one, right? This is for the second one, third one, and fourth one. So for the first one, it's right here. See? Then we have to add onto it. This is still the same formula. I just kind of ran out of space. We have to add onto it the second one, which is going to be lose 8. So it's going to be negative 8 times a 10% chance, which is going to be 0.10. See? So this right here is going to be the second one, right? Then we still have to add for the third one, but the third one is lose 5. So yes, we're adding, but instead of being a plus 5, it's going to be a negative 5. Times the 20% chance, which is 0.20. So that's for the third one. And then for the last one, for the fourth one, we're going to add again because it's still a summation, ¿cierto? Outcome times probability. Outcome is 10, negative 10 because lose, and probability being 30, 0.30. Ladies and gentlemen, from here we have the fourth one, okay? What are the observations that I can do from here? Take a quick look. The ones that are win, you're multiplying by a positive number. And the ones that are lose, you're multiplying by a negative number, see? And I know that some of you are probably thinking, why do you have plus times a negative, see? Technically, I could have just left all of these as negative and forget about it, see? But for me, in my mentality, it's very important that I follow the procedure correctly. And for me, following the procedure, if it's a summation, I'm going to put pluses all over it, see? And I'm going to put in parentheses the negatives just so that I remember and I don't mess up. And I, end up with a negative if I end up with a negative, end up with a positive if I end up with a positive. The biggest idea I can share from here is that notice all of these, as I mentioned earlier, are your outcomes. So all of these, are outcomes. And I'm putting it in blues, much like how it's in blue here. And all of these, which I'm putting in dark green, all of these are your probabilities of each of these outcomes, which is the same probability that I mentioned earlier. See? So expected value is not that hard. You just have to sort of have the intuition that it's just going to be the outcome times the probability of that outcome and all of them being added up together. Dale? If it's win, you're going to be adding your dollars, and if it's lose, you're going to be subtracting your dollars. Makes sense, ¿cierto? So that's probably as clear as I can leave it. And so for part AI, if you put all of this into your calculator, you end up with something that we're about to discover. See, so all of this into your calculator. If you just give me a moment, make sure that your calculator actually has battery in it because this guy is, falling asleep. Yeah, there we go. See? So, just add all of these together. See? So you're going to end up with the first one, which is 5 times 0.40. Plus the second one, which is negative 8 times 0.10, plus negative 5 times 0.20, plus negative 10 times 0.30. Go ahead and press enter, you end up with negative 2.8. So I was about to explain what this means, but that actually has a lot to do with part 2. Okay, so for part AI, we just found that the expected value of x has to be negative 2.8. Okay, now what does this mean? And this is part of interpreting our answer from part AI. This means a couple things, but the general idea is that if you were to play this like a lot of times, on average, you're going to be losing negative $2.8. Okay, so on average, you're going to be losing. And this also has a big implication, which is something that shows up all the time in these exercises, and I'm going to mention right away. Usually when they talk about expected value, the curveball that they throw at you, the specific thing you have to know, is being able to tell if the game is fair or not. If a game is fair, ladies and gentlemen, if a game is fair, then the expected value has to equal to 0. Okay, that means that, I don't know, if you and me play, on average, we're both gonna, sort of like win and lose the same amount. ¿Cierto? Like if we play 4 matches, I win the first 2, and then I lose the next 2, I end up at 0. Fair is fair. ¿Cierto? So that's sort of like the idea. Oh, and I end up earning in total like 0. ¿Cierto? It's not so much winning the first 2 and then losing the next 2. It's more like looking at all my earnings, I end up at 0 after all the matches. Okay, that is how you define that a game is fair. That's also why the casino always puts these weird rules so that they earn a little bit more than you, and enough people go and they end up making a lot of money. See, so all the expected values for casinos end up being negative. If it were positive, it's also not fair because that means I'm winning a lot. ¿Cierto? So for a game to be fair, expected value has to equal 0. So that is one interpretation that you can give. The other interpretation that I also mentioned was something like, I don't know, on average, people lose a lot of money, ¿cierto? On average, people lose $2.8 per game. On average, this or that. But notice, there's something very important that I'm doing here. All of my answers, pretty much all of them, are starting with the words on average. They're starting with the word on average because part of the interpretation of the expected value is that this is sort of like a long-term implication. If the expected value is negative 2.8, then usually you're gonna be losing negative $2.8. It doesn't mean that every single time that you play you lose negative $2.8. It's a long-term sort of thing. It's an on average sort of idea. And if we actually look at the answer key over here for part A double I, ¿cierto? Which is right there. I don't want you to, I mean, you can take your time and read all of them, but the main idea is, look at this, ¿cierto? Here, for this first bullet point, they say players will lose $2.80 per game, which is the same thing that they say here. Now, the one up top, which I'm now putting in red, ¿cierto? They accept it, and the one on the bottom, they do not accept it. Do not, and the ones up top you accept, the ones on the bottom you do not accept. Why do we not accept the one on the bottom? Because, you don't mention that it's on average. You don't mention anything about being long-term, ¿cierto? So it's very important that for the interpretation of expected value, we talk about on average and long-term, etc. See? The same sort of example happens down here. It's not enough to say that it's not fair. You have to, okay? You have to include the whole thing before it, which is the expected value does not equal to 0, so blah, blah, blah. See? For the interpretation, you gotta give a reason, and you have to leave very clear that you understand it has to do with the long-term, on average sort of thing. Okay? It's interesting though, here, they do mention on average, but they don't specify how much. It's like, oh, on average, players lose money. Okay, you're right. On average, players will lose money around 2.80 per game. Okay? So, what's the main idea you need to get from this? Be as specific as you can to get this point. And also, hopefully, mention at some point that we're talking about on average. We're talking about long-term. We're talking about something of that sort. So, a little bit of a long monologue there, but I think it was worth to leave clear how expected value is interpreted, how it works, etc. So that is for part A. Then they tell us that to encourage a person to keep playing this game, Zach increases the winning price for the second game they play from $5 to $6. For each successive game they play, the winning price continues to increase by 1. And our good old friend Emily plays K games, and they tell us that the Kth game is fair, and for part BI we need to find the value of K. So, a little bit hard to interpret, but if we take a moment and read it again, because for these exercises that are loaded with information, you should be reading it once or twice. I mean, twice or thrice, better said, not just once. They tell us, Zach increases the winning price for the second game from 5 to 6. And for each successive game, the winning price continues to increase by 1. All right, Zach is entirely an entrepreneur. He's trying to convince us to play his fishy game and take all our money. Zach is probably going to be a politician. Anyways, point is, this $5 winning up here for the first one, ¿cierto? This $5 winning that's up there, see? It's basically like win 5 first game. And then it's going to be win 6 second game. Which is this part here, ¿cierto? The second game it increases from 5 to 6. And we're talking about the winning price, and there's only one winning price, ¿cierto? The other 3 are lose. And so first game win 5, win 6 for second game, and win 7 for third game, see? And if I kept going, technically I have win 8 for the fourth and win 9 for the fifth. Okay, that's the general idea of like what's happening here. Okay, the hard part is expressing this in terms of math and stuff like that, ¿cierto? So Emily plays K games and the Kth game is fair. Find the value of K. Now, my expected value formula, let's rewrite it, see, for part AI. So before, ¿cierto? Before we had this, 5 times 0.40 plus negative 8, I think it was. See, negative 8 times 0.10 plus negative 5 times 0.20 plus negative 10 times 0.30. Yeah, this, ladies and gentlemen, is like what we had for part AI. See, so for part AI, there wasn't anything about the second game increasing and the third and etc. and blah blah blah. This is like for every single match. See, for part BI, this expected value formula needs to change, but just a little bit, ¿cierto? Think about it this way. The winning money, this part here, which I'm putting in yellow, this is for winning, right? The rest of them are for losing, and what they're telling us here is that the winning price is what's going to be changing. See, so this part of the formula has to change, and the rest is actually going to remain the same. Okay, the rest is going to look exactly the same, and actually give me a moment just so that I can write it down. Vale? So the rest is going to remain exactly the same, but the winning part is what we have to sort of express the K somehow. And honestly, I think it's better if I just write how it should be, and then you can sort of, and then we interpret it. Right? You do need to be kind of creative for this and find a way to express this in terms of math. Right? So, think about it this way. We still have a 0.40 probability, ¿cierto? So that is going to stay the same. But the earning 5 needs to change over time. So, it starts with 5, ¿cierto? Because that is the first game. How do you express the second game? Okay, technically, I could express the second game as like just +1, because 5 plus 1 is going to give me the 6, right? But then how would I express it for the next game? I would have to put another +1, see? And what decides if you put a +1 or not? The amount of games you've played. Okay, so that means that technically what I need to have here, ¿cierto? Is K is going to be my amount of games. We're going to have it to -1. And I'm pretty sure that works. Just give me a moment to think about it. Okay, perfect. This works. See? Because think about it. If you have that K equals 1, you're going to end up with 5 plus 1 minus 1, which ends up giving you 5 plus 0. So you still end up with 5. See, so for the first game, you actually end up with the formula up top, which is, for the first game. Makes sense. And in this context, if you go ahead and plug in K equals 2, what you actually end up with is 5 plus 2 minus 1, which is the same as 5 plus 1, which gives you 6. So it makes sense. On the second game, as they say over here, the winning price goes from 5 to 6. So boom, makes sense. And just to check if this pattern is going to keep working, for the third game, I should be winning 7. ¿Cierto? Makes sense. I should be winning 7. So if I go ahead and plug in K equals 3, you end up with 5 plus 3 minus 1. And that is what ends up giving you 5 plus 2, which gives you the 7 that we talked about earlier. See? Now, why did I show you these steps that I'm now putting in pink? Not only because it's important to check your work, but also because for an exercise like this, you will probably end up like guessing and checking. See? It's very hard, and I know it's hard, ¿cierto? I know it's hard. I know it's hard to come up with this, ¿cierto? And so on the one hand, you can study it, look at this example, understand the intuition, etc. But the day of the test, I mean, unless you're very sure about your math skills and you're also very good at math, como que, you should probably double check, see? And you're probably gonna end up guessing and checking and seeing what works, okay? So I invite you to check your work, and part B is definitely hard, ¿cierto? So I, back in my day, probably would have ended up guessing and checking here or there until it worked. And I hope I shared some intuition of how it sort of like should be. See? And if I go ahead and check the answer key over here, it's right there. See? Here they multiply by 1, which doesn't really change anything. I mean, this is what we had, ¿cierto? It's the same thing. ¿Vale? So, that being said, we just found out the answer for part B. I mean, not the answer for part B, but the correct approach. So now that we successfully expressed, you know, how to have the winning price increase over time, what we can do now is come back to reality and read again that for part BI, we need to find the value of K. Now, Emily plays K games, and the Kth game is fair. And I did mention earlier that for a game to be fair, expected value equals 0. So, if expected value equals 0, that means that this whole thing equals 0. So I end up with 0 equals 5 plus K minus 1 times 0.40 plus this whole thing that I'm putting now in red for lose. See? Remember that all of these are lose. So how much is that? Let's actually just find it out right away. How much is that? Go ahead and turn on your calculator, make sure it works. I basically can just take all the parentheses with negatives and just erase the parts that's positive. See? So all the things in red are what I have in my calculator right now. Go ahead and press enter. I end up with negative 4.8. See? So this is my current scenario. 0 equals the thing in positive with the K minus 4.8. So if you want to get K alone from here, what I would suggest is first adding 4.8 to both sides. So you end up with 4.8 equals parentheses 5 plus K minus 1 parentheses 0.40. See? Now the K, notice it's it's inside two parentheses. See? So it's actually legal if I go ahead and divide by 0.40, which is the parentheses on the outside. That it? So this goes away with this. 4.8 divided by 0.40 gives us 12. So 12 equals 5 plus parentheses K minus 1. And from here, it's, you know, straightforward. You do minus 5, minus 5. That gives me, how much does that give me? 7. So 7 equals K minus 1 plus 1 to both sides. K equals 8. So that means that on game number 8, we have a scenario where the expected value is 0 and the game is going to be fair. So for part BI, finding the value of K, we just found that K equals 8. And just so that you believe me, it is right over here. That it? So that is for part BI. For part BII, we need to explain why Zach expects to raise money from the games Emily plays. So think about it. We found that, like on the first game, because this is for first game, right? So first game, the game is unfair. So that means that for the first game that Emily plays, the game is unfair. She's on average gonna lose money. And on the 7th game, the game turns fair. So that means that everything in between, the 2nd game, the 3rd game, the 4th game, the 5th game, the 6th game, and the 7th game, Emily was losing money. Emily was losing money until the 8th game. On the 9th game, it's the first time that you have a positive expected value. On the 8th game, the game is fair. They're both at 0. And from the 7th game to the 1st game, Emily is losing money. So why does Zach expect to raise money from the games Emily plays? Because the expected value of the first 7 games is negative. Because the expected value of the first 7 games is negative. So someone please call Emily and tell them to dump their toxic boyfriend that is stealing money from her with this expected value thing, whatever, okay? Point is, that's the reason, see? Not toxic masculinity, it's just, you know, an unfair game. Anyways, we come back over here, and that is exactly what they say. For each and pretty much all the first 7 games, there's a negative expected value going on. See? Notice this is a reasoning point. You do have to express in words a little bit, ¿cierto? And hopefully give this, ¿cierto? The expected value is negative, and we're talking about 7 games. See? Anyways, that would be for part B double I. Number 12 is not super hard, but you do need to have very clear how the expected value works. See? And please keep in mind the expected value usually comes hand in hand with someone asking whether the game is fair or not. Okay? Whether the game is fair or not is a classic when dealing with expected value problems and probability and stuff like that. Okay? Anyways, that would be for number 12. And what can I say? I hope it helped.